Hello bachon, how are you? I hope that you are doing well and your examination is so close. So that's why we are here. We are going to revise all the things of the I and OR by using the questions, through questions. Okay. So as you know, this is the revision session through questions. I am having some beautiful questions, very excellent conceptual questions for you. Okay. So let us start one by one. We are going to start the questions. We'll be discussing that. So here, as you know already, you have attended the 6 or 7 sessions. Okay, this is today is my session. Here we are here. See, you can see here, there. So see how excellent problems we are having here. You are going to you are going to enjoy these problems, because the session which you are going to discuss today, this session will make the things very clear, and you will be capable to solve any question, whether it is tough or easy. Toughest question you will be capable to solve in your GATE examination, upcoming examination. Okay, so what is going to happen here? Let's say, suppose first of all, before coming to this numerical, I want to discuss you with a very important part, very important part. Okay, here it is. There is a queuing theory concept, which is really excellent concept. Queuing theory. I hope that you have seen this. You have seen this part. See, Pn equals to rho to the power n p0. Have you heard this? Can you please comment? Can you I'll be able to see your names here. See here, Pn equals to rho to the power n p0, and you know that this is what? This is the formula of having n people in the system. N people in the system at any point of time, for a steady state. Clear? You know from where this formula can be derived. We are having a very excellent concept for this. Let's say this is coming in model number 1. What is that model? Markov and single server and infinite and FIFO. You remember this or not? This is the way we represent the model. Markov, single server, infinite capacity and FIFO model. Okay. Same formula is valid for model number 2 also. Model number 2. Excellent thing I am going to discuss. This is Markov. This is single server, finite capacity. Suppose the system is having the maximum capacity is what? Maximum capacity is 100. Suppose this is given to us, and this is what? First in, first out model. Okay. Now from where this formula is coming out? Obviously you can go to the derivations, but I am going to discuss a very beautiful way, because if you are clear with that way, you can solve any toughest question in the examination. Now see this, how we are getting this part. Suppose I am just showing some, let's say this is zero state. What is that? Zero state. Okay, when you see this diagram, you can say there is nobody in the system. There is no customer in the system. There is no customer in the system. You are really going to enjoy the questions. Really. Okay, this is what? There is no customer in the system. This is what is small n. Here we can say there are n customers in the system. So this is just the representation of the state. What is that? This is representation of state. Representation, because that first 2 questions on the queuing theory which I am going to discuss today are very excellent. Representation of state. 0 state, nth state, 6 persons, 7 persons, how many persons we are having, we are going to discuss like that. Okay, now in this case, if suppose let us discuss from where this formula is coming out. Let me draw one diagram here. This is 0 state, this is 1 state. 1 state means the single 1 people in the system. This is 2 people in the system. See this is 2 persons in the system, 3 customers in the system, 4 customers in the system, and let's say 5 customers in the system. So if suppose we are discussing this, that suppose we want to go from what? We want to go from the state 0 to 1. Can you think of that, whether the arrival is going to happen or whether the departure is going to happen? So in this case, we can say when we are going from 0 to 1 state, it means there was nobody in the system, and when you are seeing at this point, you can say there is 1 person in the system. So what is going to happen? It means the arrival has happened. Arrival. What has happened? Arrival has happened here. Okay. So let's say this is what? Lambda 0. What is that? Lambda 0. Why I am calling this as lambda 0? Because this arrow is starting from 0 state. So arrival is happening when there was nobody in the system, and we are moving to what? State 1. State means one means what? After arrival we can say there is one person in the system. Similar way, suppose there is one person in the system already, and one more arrival is happening. This is arrival lambda 1. This is different arrival rate. We can say when arrival is happening, we can move from 1 to 2. Similarly, we can move from 2 to 3. We can move from 3 to 4, 3 to 4, and like that we are having people are increasing in the system. We can say people are increasing in the system. Okay. Why I am saying that lambda are different? This lambda, this lambda, this lambda, this lambda, this lambda, all these lambda are what? All these lambda are different from each other, because if suppose let us take a very practical example. If suppose we are having we are interested to withdraw the money from the ATM machine, and there is a ATM machine. In front of that there are only two people in the queue, in the system, we can say. Okay, in the system or queue, and I also want to withdraw the money. I am coming. I am very happy to see, oh, there are only two people in the system, and there is a high probability that I will join the system because there are only two people in the system. But just think of when there are 6 people or 7 people or 10 people in the row in front of the ATM and to withdraw the money, and I am just coming and I am saying, oh, there are 10 people in the system, too much crowd is here. Okay, definitely I will lose my interest, and possibly I will not be joining the queue. It means the lambda is decreasing as the number of people in the system are increasing. Lambda is decreasing. And there are some examples where as the crowd increases, number of people in the system increases, the lambda is also increasing. This is also possible. So when arrival is occurring, when lambda is occurring, we are moving to the higher state. More people are coming in the system. But when the services are being completed, see here, when the services are being completed, when the services are being completed, the number of people in the system are going to decrease. They are going to decrease. So you can say this is what? mu1. Why I am starting from this mu1? Why? Because you can see that when I am having the see, this arrow is starting from state 0, but this arrow, when you can see the departure, here you can see the arrivals. In yellow color, in orange color, you can see the departures. When you can see the departures, when at least there is one person in the system. Okay, so this arrow is being started from state 1, it is started from 2, 3, 4, 5, like that only. Okay, done. So you can see there is a mu1 service rate, mu2 service rate, mu3 service rate, mu4 service rate. And what I am saying that the service rate and the arrival rate is also the function of how many people are there in the system at that point of time. If suppose the people are higher, lambda may be different. Lambda may be increasing, lambda may be decreasing, mu may be increasing, mu may be decreasing. Now just think of, see, excellent thing I am going to discuss over here. Excellent thing. If suppose you want to find out the value of P3, you want to check, sir, what is P3? What is P3? The probability of having 3 people in the system at any point of time. So you are interested in that, and I will suggest to you, if you want to find out the P3, if you are interested to find out the P3, see how easily you can find out P3. Just stand at this 3.3. You are going to enjoy the numericals. Just wait. Okay, you are what? You are standing here. How many lambda are there to the left hand side? How many lambda? Lambda 0, lambda 1, lambda 2. So what I'll write? Lambda 0 multiply lambda 1 multiply lambda 2. I am not going to discuss the detail of this, but I am giving a very excellent technique to solve any question, any toughest to toughest question. Okay, so we are finding out the P3. These are 3 lambda just to left side of the P3, and we are having 3 mu also. Mu1 into mu2 into what? Mu3. So 3 lambda, 3 mu. Just multiply then. Lambda in numerator, mu in denominator, and just write down P0. Just write down P0. This will become P3. So can you identify the formula of general formula of Pn? Can anybody find out the value of Pn? See, here is the Pn value. What is that Pn? Very simple. If suppose I am at the nth state of the system. Nth state means there are n people in the system. I want to find out the probability of that. I will be multiplying what? All lambda, lambda 1, lambda 2, and up to what? Lambda n minus 1. If you check, when I am writing the 3, there are 3 lambda, 0, 1, 2, and there are 3 mu, 1, 2, 3. So lambda in numerator and mu in denominator. Similar over here, we are what? At Pn. So we will start from 0 and n minus 1 lambda. Now come to the mu, mu 1, mu 2, mu 3, and how many mu? Up to mu n. See, you can simply judge, sir, why this is n minus 1? Because we have started from 0. Why this is n? Because we have started from 1. That's why there is a difference in the symbols. Okay. And what is that? P0. Beta, this is what? This is the journal formula. Journal formula of the what? Of the queuing theory model. Journal formula. Whenever you want to find out the how many people are in the system, n probability of n people in the system, you have to write by this way. So you should be clear how to make this diagram. Very, very easy. And if you want to find out the any P5, P6, P7, you just stand over this value, multiply all lambda to the left hand side, divide by all mu in the left hand side into P0. Into what? P0. Are you getting this point? So this is basic formula. Now let us go to a very, very practical example, very practical question, and definitely these kind of practical questions are expected to come in GATE. Now see this question, see this. Here is the question. Now see, if suppose today is Sunday, if you go to any smart market, okay, let's say big bazaar like thing, okay, any smart market, if you are going to purchase the grocery, you know Sunday what is happening? There is a big store, in a mall. Here you can purchase, and here are the billing counters. These are billing counters. You can see these are billing counters. Okay. Billing counter 1, billing counter 2, billing counter 3. Sunday, if you check, all the billing counters are busy because Sunday the most of the people are coming to the mall and they are going to buy a lot of things. Okay. But if suppose I just take the example of the Wednesday and noon, not evening, noon. Can you judge that how many billing counters will be in operation? How many billing counters will be in operation? 1 or 2, all 3, or let's say all 7 are not working. Whatever the number of counters are there in the mall for a big bazaar, all billing counters are not in operation. Are you getting this point or not? So definitely there is a manager of this shop. Who is going to decide on the basis of the crowd. If the crowd is high inside the shop, the number of billing counter in operation are going to increase. The manager has to increase the number of billing counters if there is a high crowd in the system. Now see this. Check this data. If number of customers in store, how many customers are in the store? 3. If 1 to 3 customers are in store, only one billing counter is in operation. If the crowd is moving, is increasing from 4 to 6 number in the system, customers in the system, the number of counters in operation 2. And if suppose the crowd is more than 6, okay, then the number of counters will be 3, and we are having maximum 3 counters. So here is the manager who is going to decide that how many, at what time, in what condition, how many of this billing counters must be in operation. And what we can assume is, we are having 1 mu here. Every counter is having its own service rate. So this is 1 mu. This counter is also having the mu service rate. Means what is the service rate? How many customers can be billed in 1 hour? Okay. Bill means what? Billing. Okay. So definitely this counter, the person who is working at this counter can serve 10 people in 1 hour. This can also serve 10 people in 1 hour, suppose, and this can also serve 10 people in 1 hour. Now, if all 3 are working, suppose, just think of, if all 3 are working, you can say that the service rate is 3 mu. If only 2 are working, just think of, if 2 are working, you can say the service rate is 2 mu. What is that? 2 mu. And if single is working, if suppose only one counter is in service, only one counter is in service, we can say service rate is mu. I hope you are clear with this point. Okay, now what I am going to do, I am going to draw that diagram. Which kind of diagram? This kind of diagram I am going to draw, and you have to check that what should be the mu at which condition, So let us find out what is happening here. This is manager. Okay, so I am going to make the diagram here. Really excellent and very practical question. Very practical question here. 0, 1, 2, 3, 4, 5, 6 and 7 and so on. Any number of people can come in the system. Now can you please check, can you please identify that what value of mu should I write here? What value of mu should I write here? Lambda, see, I'll show you that value of lambda is what? The value of lambda is what? The value of lambda is constant. Value of lambda is constant. See this. Here is the data. Customers are arriving in the system at a mean rate of 10 people per hour. 10 people per hour. And one checkout counter can serve how many people? 12 minutes. One counter is taking 12 minutes to do the billing of the one person. What is the value of lambda? The value of lambda is 10 customers per hour. And what is the mu? One billing counter can serve one person in 12 minutes. Then how many people the person can serve? The billing person can serve. The person who is doing the billing, he can serve 5 people in 1 hour. So the arrivals are coming at this rate, and each counter can serve the people at this rate. They can do the billing only for the 5 people in 1 hour. Are you getting this point or not? Okay. Now see this. I am going to make the diagram for this. Yeah, check this. From here to here, from 0 to 1, if you are going from 0 to 1, lambda is occurring. From 1 to 2, lambda is occurring. From 2 to 3, lambda is occurring. From 3 to 4, lambda, like this, and this. So lambda is constant. But the mu is variable. Please remember, up to 3 people in the system. Only one counter is working. So what I can say is 1 people in the system mu, 2 people in the system mu, 3 people in the system mu. Only one counter is working. But as the number increases from more than 3, if you check, if the 4 to 6 people in the system, number of customers in the store, if that is 4 to 6, two billing counters will come in operation, and the service rate will become twice. So here you can say 2 mu, here you can say 2 mu, here you can say 2 mu. Okay. And now you can say what? You can say, sir, 7 people. 3 mu. More than 6. Please remember, more than 6 is what? More than 6 people. If there are more than 6 people in the system, the service rate will become 3 mu, because all 3 counters will be in operation. Now if you check this, what they are asking for, you are going to enjoy this. See this. See what they are asking. Find the probability. What they are asking? Determine the probability that a customer has not to wait for the service. Okay. It means we can say what we are going to find out? We are going to find out the P0. When there is nobody in the system, at least one counter will be working. See, billing, the person will be standing at the billing counter. If there is nobody in the system and you are purchasing at first, there is no wait for the billing. You can directly go to the counter and your billing will be processed. Okay. So see this. Excellent question. We have to find out the what? We have to find out the P0. So this is the complete diagram. Now let me write down what? Let me write down the basic formula. P0, very basic formula I am going to write down here. If you are clear with this concept, you can solve any question, dear, any question. See, P0 plus P1 plus P2 plus P3, okay, plus P4 plus P5. See, I just for the practice I have taken a long question. They will be giving for the 2 counter. I have taken the 3 counters. They will be taking the 2 counters in gate. Okay. So P4 plus P6 plus P7, P8 and so on equals to what? Can you tell me what is the value of this? Equals to 1. Equals to what? 1. Clear? Dinesh, if you check this, so what is going to happen here? Now P0 is what? P0 plus. What is P1? If you check P1, this is what? If suppose you are standing here, what we have to take is lambda and mu. So lambda upon mu, P0. P0. What is P2? Lambda square upon mu square. See, what we have to do is, we have to multiply both lambda, we have to multiply both mu, and what is that? P0. What is P3? P3 is lambda cube, lambda upon mu whole cube, and what? P0. Now you can come to what? You can come to P4. I am just writing the value of P4 and you will be surprised with that value. P4 will be lambda, 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 lambda upon mu into mu into mu into 2 mu this time, 2 mu. Wherever you are standing, you have to take the just left values only left. Okay. So this will be lambda upon mu whole 4 and 1 by 2. 1 by 2. And this is what? P0. P0 plus P5 is what? Lambda upon mu to the power 5. 5. All 5 lambda, all 5 mu, but here 1 upon 2 into 2. Why 2 into 2? 2 and 2. Okay. And this is what? P0. Next, what is P6? Lambda upon mu ki power 6. And how many 2? Obvious 3 2s. 3 2. And what is that? P0. Similar over here, plus 7. What is 7? Lambda upon mu ki power 7. 7. Just think of 7. 7 lambda, 7 mu. But what is going to happen here? This is 3 2 and 1 3. 3 2 and 1 3. And what is that? P0. And similar over there, lambda mu ki power 8. 8. 1 upon 2 ki power 3 and 3 is square. And P0. And similar over here, dot 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 and equals to 1. Equals to what? 1. There is a lengthy question. Okay. They will be restricted to the 2 counters only. Okay. Now if you check, this will make a GP. You have to find out the P0 value, and what they are going to do, just take the P0 common. Just take the P0 common. Put the value of lambda 12 or 10. Let us check. Lambda is 10. Mu is 5. So lambda upon mu is what? Lambda upon mu is 2. Lambda upon mu is what? 2. So let me put that value, and within let's say next 10-15 seconds you will be getting the answer of that. I have taken P0 common. P0 common. So 1 here. This is 2 here. 2. This is 2 square 4 here. This is what? 2 cube 8 here. Then this is 2 ki power 4 and 1 2 will be cancelled out. 8 here. Lambda is 10, mu is, this is 2 ki power, this is also 8 here. 8. If you put the value of lambda 10 and mu 5, the ratio will become 2. 2 to the power 5 and 2 will be cancelled out. Okay. So 2 ki power 5 and 2 ki power 2. Only 2 ki power 3 remaining. Similar over here. 2 ki power 6 and 2 ki power 3. Only 8 remaining. 8. Now come to this part. This is 2 ki power 7. 1 3 2 will be cancelled out. So 2 ki power 4 remaining. 4 and by 3. Next is what? 2 ki power 5 and what? 3 square. And dot 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 and equals to 1. Equals to 1. Now simply you can see this is 1, 2, 3, 7, 7 and 32, 39. So this is what? P0. P0. This is 39 plus. If you check, there is a GP. This is GP beta. This is what? GP. From here to here. If you check what is happening here, this is what? GP. And the answer of this GP will come out what? The answer of the GP will come out. This is A upon 1 minus R. A upon 1 minus R. What is R? This is 2 by 3. What is R? 2 by 3, and this is equals to 1. So if you are going to solve it, this will become 1 by 3, 1 by 3. So 3 and 3 will be cancelled out. 1 by 3, 3 and 3 will be cancelled out, and 1 is there, and this 2 की power 4, 16. Okay, it's quite simple. This is quite simple. P naught 39 plus 2 की power 4, which is 16, equals to 1. So what is P naught? The value of P naught is 1 upon 55. So this is the probability that the person has not to wait for the service. The person has not to wait for the service. So that's why I am talking to you that this diagram is really very, very important. If the people are clear with this concept, they can solve any question. Okay. So obvious. This was the real example, real practical example. We solved this and we found the value of the P naught. Now let us come to the next question. Next question here. Next question is also on the basis of similar pattern. See this. This is also one of the excellent questions. Okay. There is a parking. Okay. Where 5 cars can be parked. 5 spaces are there. Only 5 spaces. If the parking is full, you can see that the cars which cannot be parked must go somewhere else. They cannot make a queue. They cannot wait. So please remember, if suppose somebody is asking what is the value of LQ, can you find out the value of LQ here? As per this diagram, as per this concept, where we are having the parking space only for the 5 cars, and if suppose you are not able to park those 5 cars in the system, the car waiting outside cannot wait outside actually. They have to go somewhere else immediately. So if somebody is asking that what is the value of LQ here, you can simply answer 0. This is the really excellent question. Okay. So because you will be finding out, so you will be getting the lambda, you will be getting the value of mu, and then you will start calculating by using the formula. Here no need to use the formula, you can simply say LQ is 0. But apart from this, they are asking something else also. What they are asking? Determine the average number of cars in the system. And what is that, beta? See, average number of cars in the lot. So they are asking LS they are asking. Okay, let us find out how we are going to solve it. What is the value of lambda, beta? The cars are arriving to the parking. Okay, 6 cars per hour. 6 cars are coming per hour to get parked, and parking time is exponentially distributed with mu is also there. Mu is also there. What is the value of mu? 1 car is being parked for the 30 minutes. 1 car is parked for the 30 minutes. So in 1 hour, how many cars can be parked in 1 hour at the same space? Please remember, we are having the 5 spaces. Do you know that how I am going to solve this problem? Actually, this is okay. Tell me, is this? It's enough, beta. Enough. Actually, these, if suppose they are going to make some variation, definitely in the gate examination, if they are going to make any variation, Yogesh, the question will be coming from this area. 100%. Slight variation, they will strike to this area. Nowhere else they can go. If you check this, we are having the LS here. LS. Okay. So first of all, whether this is single server problem, just I am asking whether this is single server problem or multiple server problem. Can you identify that? Because most of the people are not able to identify whether this is single server or multi-server problem. First of all, I'll tell you, there is a 5 spaces to park the car. Space 1, space 2, space 3, space 4, space 5. Space 5. Please remember, we are having 5 server problem. How many servers we are having? We are having 5 servers problem. This is 5 servers. Okay. Whenever you are having the 5 car parking space, don't think that 5 capital, capital N is given, capital N is also given, but for capital N is what? The capacity of the system, okay. But as well as there is not single server, we are having 5 server problem here, okay, 5 servers. Why? Because when the car is coming, let's say every space can serve 2 cars in 1 hour. Why? Because one car is being parked for 30 minutes. One car is parked for 30 minutes. Are you getting this point? So at this place, 30 minutes and 30 minutes, 2 cars can be parked. 2 cars can be parked. So what is the mu? The mu is 2 per hour for this. And similar way, we are having other four servers also. Clear? So lambda is what? Lambda is 2 per hour. 2 per hour. And what is? 5 servers. 5 servers. And also the capacity is what? The capacity also 5 cars. The capacity also 5 cars. Now see how easily we are going to solve this problem. See this. See. This is 0, 1, 2, 3, 4 and what? 5. We are having 5 spaces. 5. So this is the maximum picture you can see in the parking lot. Maximum to maximum you can see 5 customers or 5 cars in the system. Okay. Now let me give you the value of lambda. Let me give you the value of lambda. This is also one of the excellent questions. Lambda, lambda, lambda and lambda. Now what about mu? What do you think? That what is the mu? If suppose we are having one car, the mu is 1. But if suppose we are having 2 people in the system, is the second person going to wait for the turn? Nobody is going to wait. Nobody is going to wait. If suppose one car is already parked here, second customer is coming, immediately the second customer is also going to get the service. The second car will come here, the second car will come here and get parked here. Okay. So do you think that what is the service rate? Can you think of that? What is the service rate here? The service rate is, if we are having 2 people in the system, the service rate is 2 mu. When there are 3 people in the system, all 3 cars are parked, and this is the parking is only the service. So all 3 cars are getting the service at a time. All 3 cars are getting the service at a time. So when we are having the 3 cars in the system, we are having the service rate 3 mu. Similar over here, this is 4 mu, and similar over here 5 mu. That's why I am discussing this beta. That's why see the beauty of this diagram. Okay, lambda is constant, but mu is what? Mu is increasing with car. If suppose we are having 5 cars, all the 5 cars are getting service. Or service means what? They are getting parked only. Okay, they came to the mall just to get the parking. Okay, so all 5 cars are getting the service right now. So when you are having 5 cars in the system, what is the service rate? The service rate is 5 mu. 5 mu. Are you getting this point? Okay, so see this, how easily we are going to solve this problem. Now in this case also, what is the value? Let us find out the P0 first. P0 plus lambda upon mu. Lambda upon mu. Let me put the value of lambda and mu. This is what? 3. This is what? Lambda upon mu. This is what? 3P0. 3P0. Got it? What is lambda 2? Lambda 2. Lambda 2 is obvious. Left side all lambda are to be multiplied. Left side all mu are to be multiplied. Okay? As per this law, which I already told you. As per this law. Okay? So see this. How easily, what is the beauty of this? This is what? 3P0. Okay. We are going to find out the value of, see, this is P0, this is P1, P2, P3, P4. All the sum of all probabilities must come out 1. The sum of all probabilities must come out 1. So P0 is here. P1 is lambda upon mu. Now P2, come to the P2. P2 is lambda upon mu, which is 3 and 3 by 2. Lambda upon mu. So 3 square by 2. And this is what? P0. You just do this. Lambda into lambda, mu into 2 mu and P0. Come to the P3. Lambda into lambda, mu into mu. So what is that? This is 3 square. And what is the denominator? 1, 2, 3. This 1, 2, 3. Okay. So 2 into 3. P0. Now come to the P4. What is P4? 3 की power, this is 3 की power 3, 3 की power 4, and sim P naught, this is what? 3 की power 5, P naught equals to 1, equals to 1. Let me write the denominator. We are just looking for the P4, so lambda, 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 mu, 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 this is over. Lambda upon mu is 3, so 3 की power 4, but this is 1, 2, 3, 4, no, 1, 3, 4. So 2, 3, 4. Similar here, similar over here. 1, 2, 3, 4, 5. Means 5 factorial we can say. We can say 1, 2, 2, 3, 4 and 5. 1, 2, 3, 4, 5. Clear? Okay. Now simply what you have to do, you have to calculate this value. You have to calculate this value. Take the P naught common. Take the P naught common. Let me take the copy of that. I'll be taking the copy of that. Okay. Let me delete this part. We'll delete this part and we are going to calculate the remaining values. Beta, these questions are those questions which are what? Which only toppers can solve. Only toppers can solve these questions. Okay. So if you want to have good rank, very, very good rank, okay, definitely you have to go through this kind of questions. Okay. So P naught, take out this. So 1 plus 3 plus, what is that? 4.5 plus, this is what? 3, 1.5, 3 square, okay, plus, this is 3 went out, 20, let me calculate this part. Let me calculate this part. 3 cube, 2 into 3. No, this is what? This is not. This is 3. This is 9 by 2, 4.5. I think there is a mistake. What is the mistake? 9. This is again 4.5. This is again 4.5 because 3 and 3 will be cancelled out. 3 square by 2. Okay. Now let us come to the next part of this calculation. What is that? 3 will be cancelled out. 27 by 8. 27 by 8. This is 3.375 P naught. And the last one is what? 3 and 3 cancelled out. This is 81. 81 divide by 40. Is this? Yes. 81 divided by 40. So this is 2.025. Close it. And what is that? 1. Okay. So now from here we can say P0 is what? P0 is, we can take the sum of this 3.375 plus 4.5 plus 4.5 plus 3 and plus 1. This is 18. This is coming out 18.4. So this is 18.4 and 1 divided by, I'll take this value as what? This is 1 divided by answer. 1 divided by answer. This is 0.054. What is the value we are getting here? We are getting if there is a calculation mistake, you can please check that. You can please check that. Okay. So what we are getting? We are getting the value of P naught here. Okay. So we use this diagram. We use this diagram for the 5 cars. Okay. We put the sum of all probabilities equals to 1, and we got the value of P naught. Now, when you are having the value of P naught, it is quite easy to find out the value of P1. Please remember, this is what? This is P1. This is P1. This is P2. This is P3. This is P4. This is P5. This complete is what? P5, including P0. Including P0. This is P4 and this is P5. Now, let us go to what? Let us go to find out the value of what? We are interested to find out the value of LS. We are interested to find out the value of LS. So, what is LS? LS is summation NPN. N is varying from 0 to 1. Not 0 to 1. This is 0 to 5. 0 to 5. So, what is that? 0 P0, 1 P1, 2 P2, 3 P3, and what? 4 P4, and what? 5 P5. 5 P5. Clear? Done? So what values you actually, what is important? The important part was how to find out the value of P0, and already we got the value of P0 here. This is the value of P0. We went from here to here, and then we got from this value P naught. So now you can say with the, see, this is P1, this is P2, this is P3, P4, and this is P5. Now if you are going to put these values here, if you are going to put these values here, you can simply find out the answer. Let me take out the P naught outside. This is already 0 beta. This is already 0. So this is 1 into P1. What was the P1? The P1 was, I think 3. Yes, 3 P naught. So this is 3 plus. This is 2 into, what was the P2 value? P naught already we have taken out. So this was 3 square upon factorial 2. This is what? 3 into 3 cube upon factorial 3. Actually 2 into 3 is factorial 3 plus. This is 4 into 3 की power 4 upon factorial 4 plus 5 into 3 की power 5 and factorial 5. Okay. So if you are going to solve this, part, you will be getting the value. Just you have to put the value of what? P naught. Here you have to put the value of P naught. Okay. Let me check whether we are getting the correct value of P naught or not here. Yes, P naught 3. Let us check here. This is 3. Yes, exactly. Okay. Yes, absolutely. Okay. So you have to check this value whether this is correct or not. Otherwise, by concept wise, if you go, this is what? This is the complete picture. How to find out the P0 and how to find out the LS value. Now come to the next question. Now this question is based on the what? Inventory. Very excellent question. This is very excellent question. If you check, this is what? A newspaper boy is purchasing a newspaper at a rate of rupees 1.4. Okay. So this is the purchase price he is purchasing, and he is selling out the newspaper at a rate of 2.45. Okay. The demand may vary. The newspaper demand. Suppose I am selling out the newspaper at some railway station. Okay. Suppose I am keeping only, let's say 25 newspapers. I am keeping 25 newspapers. Paper, please take newspaper, purchase newspaper. Okay. I am selling out the newspaper at the railway station. Okay. And what happened? All the 25 newspaper got sold in first hour. Now I am thinking, oh, if I could have kept the more papers, suppose I will be having, let's say, a few more papers, I can earn some more money. So what kind of loss I am feeling in my brain? Shortage loss. What is that? Shortage loss. Why? Because I am keeping only 25 newspapers and the demand is coming for 30 newspapers. Now I am feeling sad because if suppose I could have kept the 5 more papers, I could have earned more money. Okay. So in this case, can you think of that? What is the shortage loss here? See this. What is the shortage loss? I'll be putting the value here. Shortage loss. CS. Okay. What is that shortage loss? If I am not having the newspaper and the demand is coming, then it means I am in shortage. And on every paper, how much I am earning? I am earning, see, I am selling out at this price, I am purchasing at this price. So what is my shortage loss? I am not able to earn this much of money per newspaper. I am not able to earn this money because of I am keeping low amount of stock. Okay. But suppose I am keeping 26 newspapers. I am keeping 26 newspapers and the demand is coming only for 25. I am having 26. Demand is coming only for 25. What is going to happen? I am short with what? See, I am not short. I am having, I over forecast the demand. The demand is coming only for 25 and I am keeping 26. It means I will not be able to sell out the one newspaper. And what will be my loss? The cost price. I purchase the newspaper at this price. And if I am not able to sell it out, definitely what is going to happen? I am going to bear this loss. So this is holding loss. This is shortage loss. The holding loss is cost price only. Because ultimately I have invested this much of money per newspaper. If I am not able to sell it out, definitely this is my loss because this is what? Waste for me. This is a scrap for me if I am not able to sell it out today itself. Okay, done. So CS is here. CH is here. This is your holding cost. If you are not able to sell it out and you have to keep the material with you, this is your loss. If there is a high demand and you are not able to meet the demand, you could have earned this much of money. You are not able to earn that. So definitely is what? This is shortage loss. Now, what data they have given? See, this question can be solved. See, this question can be solved like this. Okay. See this. You are having these two values. The demand is coming from 25 newspaper to 36 newspapers. The minimum demand is 25. The maximum demand is 36. Why I can say that? Because the sum of all probabilities, these are the probabilities. The sum of all probabilities are coming out what? Are coming out 1. So if these probabilities sum is coming out 1, nothing else can happen beyond this. Okay, nothing else can happen beyond this. So definitely what is going to happen? What is happening here? See. First of all, what is the shortcut trick? What is the smart trick to solve this question? Can you find out the value of CS upon CS plus CH? Can you find out this value? Okay, let me find out this value. CS upon, this is 1.05 and the sum of these two is what? 2.45. 2.45. Let me calculate this value. 1.05 divided by 2.45. Excellent technique I am having. 0.428. Let me take 4.3. Let me take 4.3. So easy, so easy. So, and if you see this question, it is looking so hard, but this is what? So easy. This value is coming out what? 0.43 is it is coming out. Okay. Now, if you check, in this case, let us find out the cumulative probability. Let us find out the cumulative probability. So what is the cumulative? See, cumulative probability. CP is what? CP is cumulative probability of demand. So let us find out these values. Okay. So this is what? 0.03. Then 3 plus this 0.08. Then this plus this 0.13. Then this plus this 0.23, then this plus this 0.4, not point, this is 0.38 and this plus this 0.53, yes, 0.53. Oh, just stop here. Just check whatever value you have found here, the ratio, this value, this, where it is lying, between two, which two values it is lying, between which two values. See, I can add this plus this also. It will become what? 0.65. Okay. Then 0.75. Then 0.85. I can do like this. But this ratio is coming out in which range? Which range? It is coming out 0.43. Let us find out where is 0.43. 0.3, 0.08, 0.13, 0.23. Oh, here. See here. See. Here. This is what? Here. Between these two values. 0.43 is coming. 0.43 is coming between these two values. So please remember, what is the best stock you should keep in the system where you are having the high probability of profit. Very low value of holding cost, very low value of shortage cost. Okay. So what is the best stock you should keep? How many newspapers should I keep with me, so that there will be a low probability of loss and high probability of profit? So you can see the value of this is lying between these two ranges. So the optimal stock, I can say here, the optimal stock is equals to kitna? 30 units. Just upper value. The probability value is lying between these two values. Okay. So 29 and 30, these are the newspaper numbers, newspaper customers number or newspaper numbers. So what I am going to keep, I am lying between here, I am somewhere here. Okay, so I am just going to take the upper value. So the optimal stock which should I keep in the stock is what? That is 30 units only. 30 units. Tricky question. So no need to do anything else. Just find out the shortage cost, find out the holding cost, take the ratio of shortage upon holding plus shortage, and write that value, search that value in the cumulative probability. Wherever it is going to lie, that is your optimal stock, your best stock. That's all. Okay. Now come to the next question. Next question. So this answer is already done. This is what 30 newspapers. Okay. Now come to the next one. Okay. If you check here, babies are born in a sparsely populated state. So some babies are being born there in some state. Okay. And at what rate the birth is happening? One birth is happening in every 12 minutes. In every 12 minutes, one birth is happening. Okay, done. So if you check this, what is the value of lambda? 5 births per hour. 5 births per hour. In every 12 minutes, one birth is taking place. So 5 births in 1 hour. Okay. What they are saying, birth certificate. The time between births follow exponential distribution. Definitely this is in your syllabus. Exponential is in your syllabus. Okay. Find the probability of issuing 50 birth certificates. In 3 hours. Okay. 50 birth certificates are to be issued in 3 hours. Okay. Given that 40 birth certificates are already issued in first 2 hours. First 2 hours. It means they are asking, it's a kind of base theorem question. You have to, why they are saying that what is the probability of issuing the 50 birth certificates in 3 hours, out of which 40 certificates you have already issued in first 2 hours. It means what is the pending part? What is the pending work there? The pending work is, if you check beta, the pending work is what? Pending work is only 10 certificates are pending. 10 certificates in 1 hour to be issued. And we have to find out the probability of this. Do you know that what is the beauty of this question? Because already they have given exponential. What is the use of this exponential? The use of this exponential is that we are following the forgetfulness property. Negative exponential distribution is having the memoryless property. So whatever happened in past, it is not going to care of that. It is always going to talk about the future only. Whatever is planning in the future, whatever is your future plan, it is going to, the exponential distribution is going to talk about only that. It is nothing to do with the past. So how many certificates you have issued in the last 2 hours, it is not going to it doesn't matter for us. They are just asking find out the probability, so that 10 certificates in 1 hour to be issued. That's all. Okay, clear everyone? Okay, so now what is going to have exactly beta? This is what 5 mastermind. This is what 5 births per hour. Can you find out that how we are going to solve this? Do you remember what is the poison? They are not asking the time, they are asking the numbers. Probability of numbers. Okay, can you answer it? That number follows which distribution? Tell me. When the time follows negative exponential distribution, when the time follows, I'm just asking you, when the time follows negative exponential distribution, time follows what? NED. What kind of NED it is going to follow? FT, let's say mu e to the power, yeah, lambda, you can say lambda also, lambda e to the power minus lambda t. This is what? Then what kind of distribution the number are going to follow? Number of persons follow, yeah, number of customers follow, persons follows Poisson distribution. What is that? When the time is NED, the number is what? Poisson distribution. And what kind of distribution is that? PNT. Do you remember that? E to the power minus lambda t to the power n upon factorial n. This is the distribution of numbers, the Poisson. What is that? Poisson distribution. So can you answer now? Can you answer this? We have to issue 10 certificates. Already 40 has been issued. We are not bothering about that. In next 1 hour, I have to issue 10 certificates. And what is the probability that I will be capable to do that? Okay, capable. This is the distribution. And now let me put the value. Are you looking for this? Are you looking for this, beta? Just check this. Yes, sir. In 1 hour, 10 certificates. Remember or not? Probability of 10 people in the system in 1 hour. Okay. So we are looking for that. So see this. See. E to the power minus, what is the value of lambda? 5 per hour. What is the value of lambda? 5 per hour. Okay. What is the value of t? 1 hour. Lambda is 5. T is 1. And how many certificates? 10 certificates. Divide by how much, beta? Divide by 10 factorial. Divide by 10 factorial. Okay. And when you are going to solve this, let me find out the value. Let me find out the value. 5 to the power 10 divide by 10 factorial. This is what? Divide by oh sorry, 5 to the power 10 divide by 10 factorial. This is 2.6. okay, this is 2.69 divided by e to the power 5. Now we have to solve this. Divide by e to the power 5. This is coming out 0.018. 0.018. Clear? Done. So this is the way, the beautiful question, the easiest question, okay, and probable to come in gate. Clear? So obvious, they were asking for the probability to issue the 10 certificates in 1 hour. Simply you can say exactly SD. Your answer is absolutely correct. What is that? We are getting this value. Okay. So we have completed the 4 questions. Now let us come to the next question. Yeah, a manufacturing company requires a component at an annual average rate of, okay, annual average rate. The D is given. What is that? The D is what? This is D. 1000 units are required in a year. In a year. The ordering cost is also given. The CO is also given as D. This is what? This is ordering cost, CO. This is lead time. 5 days is what? L, lead time, or we can say LT. We can say LT, lead time. Okay. The holding cost is 15. The holding cost is 15 CC. Now let us check what they are asking for. Okay. The plant operates 250 days. Okay. 250 days plant is operating. It is assumed that a daily demand, okay, daily demand is normally distributed. It means it is a model from the probabilistic inventory. Okay. So the daily demand, daily, please remember per day. Per day demand is what? Is 4 units. Okay. So this is consumption rate, C per day. See, this is C per day. And the daily standard deviation is 1.2 units. Okay. Sigma is also given. So we can say consumption rate is what? The daily demand is 4 units. 4 units per day. Sigma is also given. Sigma is also given 1.2 units per day. Now let us check what they are asking for. They are suggest an inventory policy to control the inventory of the item. It means actually they are saying that suggest a policy so that there will be a what? 95% service level. What is the meaning of 95% service level? 95% service level means how much I am confident the shortage is not going to happen. The shortage is not going to happen. Okay. And when the shortage is going to happen? When you are not having the proper planning of reorder level. If suppose the quantity is very less and then you are going to order for the next receipt, okay, next lot, then definitely you will be going in the shortage. So please remember, the reorder level is going to save you, okay, to protect you from the shortage. And see, nobody can give the guarantee of the 100% planning, 100% avoiding the shortage. You are just planning the possibility of 95% only, 95. So here what is going to happen? What is going to happen? Let us check. Let us check. What we can do is the reorder level. We are going to find out the reorder level. What is that reorder level? C into LT beta. This is really very important for gate. This question is very important for gate. Okay. Actually, already you have done the PYQs. Already you have attended some more lectures also. Okay. In lectures also, in DPP also, we have covered lot of questions. Here revision is being done, as well as I am trying to cover all those variations which are possibly going to happen in the gate this year or next year. Are you getting this point? Okay. So 6 units per day, I guess, sir. Mastermind, let me check beta. What is the reorder level? Reorder level is 4. This is consumption rate per day. This is lead time plus Z sigma root LT. This is the formula which I told you in the lecture. Please remember, this is the formula which I told you in lecture. This is per day. Sigma is given per day. And how many lead time? What is the lead time? The lead time is 5 days. So the sigma is going to happen for 5 days. It may happen for 5 days. It may happen. This is daily demand. This is daily demand for daily variation 1.2. Average variation is 1.2. So we have to use this formula to find out the value of what? Reorder level. Really very important in this case. So what is the value? 4 into what is LT? LT is 5 days, I hope. Yes, 5 days plus what is the, can you please tell me, mastermind SD, can you please tell me that what is the value of beta? What is the value of Z for 95% confidence level in inventory? Please remember, in inventory. Please remember, inventory is one tail operation. One tail operation means what? If the demand is coming below, you are never going to fail. You are only going to fail when the demand is more than your stock. More than. What is two-tail operation? The two-tail operation is, suppose I am working in Swiggy and I am a delivery boy and I am instructed to deliver the hot food. The temperature of the hot food should not below 35 degrees Celsius, not more than 55 degrees Celsius. So this is two-tail operation. If the food temperature is 35 degrees Celsius below, then it is waste. If this is more than 55 degrees Celsius, then also it is waste. So this is two-tail operation. But in inventory, you are going to fail only when the demand is greater than your stock level, not below than your stock level. You are never going to fail. So this is what? This is one tail operation, one tail, and definitely your answer is correct. The answer is what? The value of Z is 1.65, 1.65. And what is sigma? 1.2. And what is lead time? Root 5. So what is your, see, if you want to have the 95% confidence, how much quantity should be there in the inventory when you are going to make the next call? Okay, please send the material, take my next order. When you are, how much quantity is there, must be there in the stock, so that you can say, I'm just going to make I'm just going to place the next order, so that you will be getting the delivery on time, okay. So what is that value? This is 20. And if you are going to solve this, this is 1.5. I remember this answer also. This is around 4.6 something. 4.6 something. Okay. So let us check 1.65 into what? 1.2 into root 5. This is coming out 4.4. Bilkul 4.43. So this is 24.43. And we can say the answer is what? 25 units. 25 units. Okay. So 25 units is what? Is the final answer. So what is the suggestion? The suggestion is what? The reorder level must be what? Must be 25 units. If you are having the 25 units remaining in the stock, immediately place the next order. Don't delay the order. Don't delay. Okay. So, and one more thing, SD mastermind, one more thing beta. Do you know what is the name of this? Do you know what is the name of only this part? Only this part? The whole thing is called as reorder level. But can you suggest a name, mastermind, for this part? Only for Z sigma under root LT. Do you know what is that? This is reserve stock. Please remember this. If they are asking for the reorder level, do the complete calculation. But suppose they are just playing with your knowledge. They are just saying what is the reserve stock. The reserve stock is just above the mean demand. Above the mean demand. This is no, not minimum. This is reserve stock, not minimum inventory level. See, when first you are keeping this in inventory, then you are building up this inventory. So this is not minimum inventory level. This is what? This is reserve stock. Clear? So this is your mean demand during lead time. So I'll write this also. C into TL is what? Suppose they are asking for the mean demand. Suppose they are asking mean demand during lead time. Mean demand during lead time. Lead time. What is that? The mean demand during lead time is what? This is how much? This is, let's say, C into LT. Consumption rate per day into LT. But if suppose they are asking for the reserve stock, what is that? This is Z sigma under root lead time. And if suppose you are adding this, let's say this is 1, this is 2, and what you are going to do is you are going to do 1 plus 2, then you can say this is what? ROL. You have to keep this in mind. Okay, done. Now let us go to the next question. Now the following table gives data on normal time and crash time. Okay, normal time and crash time is given to you. Cost is also given. Draw the project network. Find the minimum total time of project. First of all, I want to make two things very clear to you. Okay, just see this. Just very important. This is related to crashing. This is related to what? Crashing. See this. What is going to happen here? Case number 1. If minimum cost of project to be found, then do crashing, when indirect cost per day is greater than cost slope. Please remember this. I'll make the question same data. I can make 3 questions, and please remember the people are getting confused. You people are going to confuse. Okay, that what is happening, in what case, how to proceed. That's why I'm discussing every point of the crashing. Clear? See this. If minimum cost project is to be found, then please do the crashing when indirect cost is greater than cost slope. Second case. If minimum time of project to be found, then do crashing. Up to maximum limit, then find project cost. So see, for the same data, there is a data. Okay, I am going to discuss about that. So we are having 2 questions in 2 variety of questions. Data is given. Just think of this. Data is given, and what I am saying is find out the minimum time to complete the project and corresponding cost. Listen very carefully. Very important. Find out the minimum time to complete the project and minimum cost, corresponding cost. Second, find the minimum project cost and corresponding time. Are you able to identify the difference between 2 statements? Nothing. Chaudhary, no need to bother beta. When coming to the mocking or solving problems, I am writing formula wrongly. I'll do one thing. I'll give you a simple idea. Just 2 or 3 days. Keep a blank paper in front of you. Just write the formula on your remembrance. Okay. Not write the formula at the time of test only. Okay. Just before going to sleep, just decide, give 1 hour every day. Give 1 hour every day to write the formula on the A4 sheet only on the basis of remembrance, and write down those. Wherever you are doing mistake, just correct them and keep the paper just below to your pillow and sleep over there. Really, it is going to definitely it is going to do the magic. Please remember that. Okay. But first of all, what I told you here, so can you tell me what kind of case here, what kind of case this is? Case number 1 says minimum project cost, then corresponding time. Case number 2 says minimum time, then corresponding cost. Which kind of question this is? Tell me. Which kind of question this is? Tell me fast. Tell me. What you are going to discuss here? Find the minimum total time. It means case 1 or case 2. Just check. And corresponding cost. And the corresponding cost. People are doing mistake here. Are you getting this point or not? Okay. Clear? Okay. So what is going to happen? Here they are asking for the case 2. Yes, SD. They are asking for the case 2. And let us find out the corresponding value. So here is the data. Okay, you also draw the chart. No need to see my solution. Let us check that who is going to solve first. Okay, and if you are going to solve first, definitely I will be more happy. Okay, I will become more happier. Please remember that. Okay, so you also work on this data. Let us check that how. Okay, any indirect cost is given. Okay, I am giving you one indirect cost. Suppose right now I'll delete that. Please remember, I'll delete that. Indirect cost rupees 200 per day. Suppose. Okay, first of all, you and me both are going to find out the cost slope. And what is cost slope, beta? Cost slope is the additional expenditure to do the activity 1 day earlier, 1 day in advance. Okay, so let us find out the cost slope for each activity. Here normal time 6 days. If I do the crashing, I can complete that in 4 days. It means how many days I can save? SD mastermind, how many days I can save, beta? 6 days and 4 days. How many days I can save? Only 2 days I can save. But how much extra money is required? 40 rupees is required. 2 days, but in place of 60 I have to spend 100 rupees, so 40 rupees extra required. So what is the cost slope per day? 20. What is 20? SD mastermind, are you clear with this point, beta? 2 days I can save, but there is an expenditure of 40 rupees more. So definitely what is that? 20 rupees. So next value, 2 days. Oh, 140 rupees. 70 rupees cost slope per day cost 70 rupees. This is 2 days and this is 100 additional expenditure 100. So 50. Let's say 3 and 1, 2 days, 10 rupees. Oh, I am very happy to see this 10 rupees. Very happy. Okay. This is what? 2 days and 110 rupees, 55. This is what? 4 days. This is again 55. This is what? 2 days, 30 rupees. 1 day, and this is 35 rupees. I am just asking you, okay, how much, Mohammed, how much crashing you are going to do to minimize the cost? I am saying just do the crashing and reduce the cost. Your answer is correct. Sir, I am not going to do any crashing. Why? Because the cost slope is what? See, is this? Tell me. Are you not going to do any crashing? Mastermind, batao. Mohammed, SD. Are you interested to do the crashing or not? Mastermind, please remember, I will do maximum crashing. Maximum crashing I will do. Maximum crashing. You know why? You know why? See this. See, just see this. If I complete the project one day earlier, suppose I am using this activity. Suppose this is, I'm not discussing in the reality. Suppose this is critical activity, and I am crashing this. 70 rupees I am going to spend. What will be my saving? What will be my saving? 200 rupees I am going to save. SD Mastermind, just think of, beta, just think of. If suppose I am doing the crashing on over this path, just think of, just think. Indirect cost is what? Indirect cost is greater. I will be happier to do the crashing, because if I do the crashing, I'll be spending 70 rupees more if this is critical. Okay. I'm just taking the example only right now. I will be discussing this completely. So if you do any crashing, either you will be spending 55 rupees, 70 rupees, 20 rupees, 35 rupees, and you are going to save every day. Your project will be completed one day earlier. Every day you are going to save 200 rupees. Don't you think that this is the perfect time to do the crashing? And the maximum to maximum crashing we should go for? Tell me. Why you are saying that sir, I am not interested in crashing? Why? I am just spending 70 rupees and I can save 200 rupees. This is the best opportunity. That's why I have written that part. Just if the indirect cost is this, then do maximum crashing. Do the crashing, because you are going to save the money. You are going to save the time as well as you are going to save the money also. Okay? So please remember this statement. These statements are very important. Very important. Okay? Done? So first of all, now come to the basic question. No indirect cost is given. Right now, no indirect cost is given to us. So I'm not bothering about that. Okay. Let me delete this also. See, they are not giving any indirect cost. Okay, if not given, I will be taking this as at 0. What they are asking for? Find the minimum total time. Now let us find out the minimum total time. Okay, let's come with me. Okay, come with me and let us try to solve this question. Let me take the picture of this. So that I'll be seeing the picture and I'll use this data in next slide. Okay. So let us do the network. Let us draw the network diagram. Okay. Can you solve this? Okay. 1, 2, 1, 3. I'll be writing the normal days. Okay. I'll be writing the minimum crashing which I can do. And I'll be writing the cost slope also, 20 rupees. What is that? 20 rupees. Similar over here. This is 4. The minimum time is 2. And the cost is what? The cost is 70 rupees. 70. This is the easiest way to do this. 2 to 4, 3 to 4, and 2 to 5. So 2 to 4, 5. This is 5 days. Minimum 3 days are required. This is minimum time after crashing. And this is 50 rupees. At the rate, I can write down at the rate 50 rupees. This is 2, 4, 2, 5, 3 and 1. And at the rate, if you check at the rate, 3 and what is that? 2 to 5. 2 to 5 is 3 and 1. This is 10 rupees. 3 and 1, 10 rupees. Then 3 to 4. 3 to 4, this is 6. And the minimum time is 4. And at the rate, how much? At the rate, 55 rupees. Then 4 to 6, 5 to 6. 4 to 6. 5 to 6 and 6 to 7. 6 to 7 is 3. The minimum time is 2. And at the rate at the rate 35. 4 to 6, 8 to 4, 4 to 6, 8, the minimum time is 4, and this is what, 55 rupees. 55 at the rate 55. 4 and 5 to 6. 5 to 6 is 4, the minimum time is 2, and this is also at the rate 5 to 6, 30 rupees. What is that? 30 rupees. Now complete data is on the screen and it is quite easy. Really, it is quite easy to solve it now. See, first of all, I am interested to do the crashing. Where is the critical path? Where is the critical path? Can I say here is the critical path? This is the critical path. Please check 6 and 5 and 8 and this is 7. This is the critical path. But before going for the direct crashing, please remember this is a really very good habit. Very good habit. Write the path and the time. Path and the time. So how many paths I am having? 1, 2, 5, 6, 7. 1, 2, 5, 6, 7. How much time it is taking? Right now it is normal time is 6 and 3. This is the bracket we are having the crashing time. Crash time, okay. 6 plus 3, 9. 9 and 7, 16 days. The critical path is 1, 2, 4. 1, 2, 4, 6, 7. Okay. This is 22 days. I have already calculated this. 11 and 11. Okay. Then 1, 3, 4 and 6 and 7. This is what? 4 and 6, 10, 10 and 11, 21 days. Please remember. Okay, blindly, how many days crashing you can do? Can you tell me? Blindly. See why I am writing this? Because blindly, how many days crashing you can do? Blindly. Only 1 day. Only 1 day, beta. Why? Because if suppose you are doing the crashing over this path, let's say you are making this 20 and there is no impact coming on 21. See, if you can make this, if you are making this 20, the project will not be completed in 20 because the longest path is taking 21 days. So if I ask you that blindly you can do how much crashing, only 1 day crashing can be done. Only 1 day crashing can be done here. Are you getting this point? Okay. Now if you check, let us do the crashing now. So, okay. So where is the, on the critical path, where is the least cost slope? The 20, the 50, the this and this. Okay. Here is the minimum. This is the minimum. Okay. Minimum. So what I'll do, I'll make this as 5. I'll make this as 5. And this is what? 1, 2. This is activity 1, 2. So it will become what? It will become 15 because 1, 2 is here. 1, 2 is also here. 1, 2 is also here and it will become what? 21. And this will remain 21 only. This will remain 21 only. 21 only. Got it? Done. Now 1 to 2, yes. What is the next part? The next part is what? The next part is again do the crashing. Where? Now we are having 2 critical paths. Oh my God, what is happening here? We are having what? We are having 2 critical paths. You can see this. We are having 2 critical paths. 2 critical paths here. Okay. So definitely when we are having the 2 critical paths, then what is the answer? See, the crashing is to be done on both the paths. The crashing is to be done on both the paths. So either we have to select the common activity which can impact both the paths, or we have to go to individual activities on both the paths. Either take a common activity which is common to both critical paths. If you crash that, the impact will come on both the paths. Otherwise, you have to take the individual. Let us check. It is the matter of cost, and let us check that how much crashing I can do there. Okay. See, if suppose I do the crashing over here and over, 90 rupees is the expenditure. 20 here and 70 here. 1 day crashing here, 1 day crashing here. No. This is what? 55 and 20. This is 90 rupees matter. This is 20 here and 55 here. What is that? This is, so all the options, all the individual options. Very good, SD, very good. The correct option is what? The easiest is what? The not easiest, the cheapest. We can say cheapest. The cheapest one is here only. So let me do the crashing for 2 days and make a circle here. Why circle? Because we have already reached to the minimum time. We have already reached to the minimum time. Are you getting this point or not? Clear? So this is 2 days. Now, what is the next option? SD, can you tell me what is the next option here? The next option is, let us check where is the next option. This is costly. Obvious, this one. 55 rupees is the least cost. Okay. But before going to that part, 6, 7 is common to all. So it will become 14, it will become 20, it will become 20. Now this is again common. So make this direct 4 days crashing. Direct 4 days crashing. Yes, direct 4 days crashing. 55 is the least cost. So 4 days crashing no, it is not common here. 4 6 is not here. 4 6 4 6 is here. 4 6 is here. So it will remain 14. It will become 16. It will become 16. 16 16. Okay. Now where is the next choice? Here complete crashing we have done. Here complete crashing we have done. Now let us go to the let's say we are having 2 critical paths. Now we have to take the individual activities. It is the matter of 90 rupees. It is the matter of let's say 75 rupees. It is the matter of 105 rupees. It is the matter of this combination. So the cheapest, ST, can you tell me what combination is the cheapest one? What combination is the cheapest one? The cheapest one is 1 to 2 and what? 3 to 5. 1 to 2. So I am making this as 4 and I'll make a circle because complete crashing has been done, and I'll make this 6 as 5. I'll make this not 5. I'm not going to make the circle here. It will become what? It will become 5. So this is 6, 5 will become 4 and this 6 will become 5, 2. Okay. So definitely this 1 2 is coming here. 1 2 is coming over both paths. It will become 13, it will become 15 and it will become 15. Now you are having this option. How much crashing you can do? 2 days crashing you can do here. But which one you are going to select? Which part you are going to select with this? This is 50 rupees. I am not going to suggest this one. So 1 crashing here. See, 1 crashing here. Let's say 4 days. 4. 1 crashing here. 4. And make a circle here. Make a circle here because this is what? So this 13 will remain 13. This 15 will become 14 and this 15 will become 14. 3 and 4. Exactly, SD. What is that? 3 and 4. Exactly. Okay. Now what is happening to the next part? What is happening? Now we are having only 1 day crashing remaining here. 1 day crashing here. This is already done. This is already done. This is circle, circle. So the last crashing which I can do is, make this as 3, make this as 3 and make this as what? This is at 3. Now if you check, this will remain 13, this will become 13, this will become 13. No more crashing can be done. No more crashing because already whatever potential was there, we have used that there. So over this path, we have used the complete potential of crashing. No more crashing can be done here. 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 So if you check that part, the minimum time is what? As per question, they were asking for the minimum total time. And what is the minimum total time? 13 days. So I can write here minimum time. Minimum total time. Minimum time to complete the project is 13 days, beta. Okay. And what is the cost? Now, can you calculate the cost of this? See, it's quite easy. Total cost now. Total cost for 13 days. First of all, come back to this part. Add the normal cost. Add this part. What is this value? This value is 60 plus 60 plus 170, and let's say 170 and 45, 215, 305, 385 and this is 470. This is what? 470. Now come to this screen. But remaining cost we can find out from here only. Okay, 470 is the normal cost plus crashing, and directly from the screen you can find out the crashing cost simply. You can say this was 6 and you have reached to 4. 2 days crashing, per day 20 rupees. This is already written. So 40 rupees here. 40 rupees plus. Here 1 day crashing, per day 70 rupees. 70 here. 6 you have made 4. 2 days crashing at a rate of 55 per day. So 110 rupees. Here 2 days crashing at a rate of 50. 100 rupees plus. Here 4 days crashing at a rate of 55, 220 rupees plus 1 day crashing at a rate of 35, this much. And if you check that, what is the value? The value is, if you check this, 40 plus 70. We can calculate like this only. 40, okay. 40 plus 70 plus 110 plus 100 plus 220 plus 35 plus 470. What is the total cost? Exactly, mastermind, bilkul exactly correct beta. What is this? 1045 rupees. See, every question I made somewhat long. This much of long question is not going to come in gate. They will be reduce this by, let's say, 20% or 30% just by directing the data. But just to have the good practice, that's why I am keeping the things longer. Okay, done. No, this is not 108, 1045. Exactly, SD, the answer is what? 1045. Exactly. Okay, so by this way you got the answer. This is a very good practice. This is the very good practice to do the crashing, because every time whatever crashing you are doing, this is giving the idea whether the critical path is being changed or not. And this is really very good practice. Okay, now come to the next question. Now here the demand for an item is deterministic and constant over time, and it is equal to 24,000 units per year. Okay, demand is deterministic and constant over the time, and it is equal to 24,000 units per year. Done. The company can produce the item at a rate of, okay, company can produce, days are given, any days, yeah, rupees, any days are given here. How many days the company is working? No. The setup cost is given, carrying cost is given, the shortage cost is given. Determine the, oh, excellent question, really excellent. Now see this is coming from inventory and they are asking for the maximum inventory level. Okay, so demand for item is given, it is equal to itne per year. The company is producing this much of per month. Done. See this, company can produce, if you enjoy, you are definitely going to enjoy this question. This is 4,000 per month. Can you tell me what is the consumption rate per month, bachcho? Can you tell me, beta, what is the consumption rate per month? Tell me, what is the consumption rate per month? Can you answer it? Tell me. This much of unit per year. So what is the consumption rate? Yes, I can produce at a rate of 4,000 per month, but what is consumption rate? This is second model of inventory, second model. Okay, when the incoming rate of material is greater than the outgoing material rate. So you can say, sir, 24,000 per year. So in a month we will be consuming the 2,000 units per month. 2,000 units per month we are going to consume. So P is given, C is given, shortage cost is also given. Really excellent question. Now see this. What is the value of Q? What is the value of Q? The value of Q is, this is first model, this is C naught D by CC into what, beta? This is P upon P minus C into what, beta? This is CC plus CS. Do you remember that part or not? This is what? CS. This is model number 1. This is the factor which is taking care of P and C. This is the factor which is taking care of shortage. Can you calculate this value, beta? Can you calculate? Good. Mastermind, bilkul exactly, beta. What is the answer? 2000. Okay, 2000 units per month. Now, can you put these values here and find out the value, the QEUQ, the order quantity? Setup cost is this. D is, the yearly D is 24,000 divided by CC. CC is 20 paisa per unit per month. 20 paisa per unit per month. Please remember. So what I am going to do? 20 paisa per unit per month. Let me multiply with year. Let me convert this into year. P is 4,000. P minus C is 2,000. P minus C. And CC and CS. What is the C? What is the shortage cost? Oh, shortage cost is 300 per year. 300 per year. Clear? So either you convert this into month or you convert this into what? You convert this into year. You are having only two choices. Either you convert this into month. So what I am doing, I am converting the CS per month. So let me divide this by 12. It will become 25 rupees. It will become 25 rupees. So let me put the values in month, either both values in month or both values in year. It's your choice, okay? So CC is 20 paisa, 0.2 plus 25. This is per month beta. CS per month. Per year 300. So per month shortage cost is by 12 kar denge. This is what? This is divide by what? CS 25. What is the value coming out? Can you please help me out? Can you please help me out in this calculation? Let us check. Let me calculate this part. 2 into 600 into 24,000 into what? 4,000 into what? 25.2. Divide by 0.2. 12. 2,000. Please check whether you are getting this value as 4918 units approximately. Exactly. We are getting what? 4919 units. What they are asking for? They are asking for the maximum inventory level. Please remember, this is not maximum inventory level. What is that? What is that? Sir, this is the maximum quantity which we have ordered, sir. This is what? This is maximum quantity which we have ordered. Okay, then how much is coming in the inventory? How much coming in the inventory? Very excellent thing. Now let us check the maximum inventory shortage level. Maximum shortage level we are going to check. What is that? This is CC upon CC plus CS. Similarly, P upon P minus C upon P. P minus C upon P. And what? QE. Please remember this formula. Decimal beta, decimal values. And they will be writing, see, in question itself, they are going to mention that give the answer up to 2 decimal places, 3 decimal places. They are going to give you that clue. And please remember, no round of value, you are going to put the value. If not given, you have to put the value in what? In integer only. Not in, what is that? Integer. Clear? They will be giving the clue. Please remember. Okay? Done? So, clear? What is going to happen here? CS, this is what? CC. CC, please check. 0.2 divide by 25.2. This is divide by how much? P is 2000. Okay, multiply by 4919. How much this value coming out? Please check. How much this value is coming out? CC plus CS, P minus C upon this. What is the value? P minus C upon P. Please find out this value. This is 2000 upon what? Okay, let me write 0.2 upon 25.2 into. This is P minus C is 2000 upon 4000 into 4919. What is this value? 0.2 divided by 25.2 divide by 2 into 4919. This is coming out approximately 20 units. You are not going to take the approximate values. Please remember, you are not going to take the approximate values. No, SD it is coming out. It is coming out 20 only. Please check. It is coming out 20 only. Okay, may be possible you are giving the final answer 19.5. Please remember, in examination you are going to take the 19.5 only. Okay, now we are having QE. We are having the value of S. This is the special case of mixture of model 2 and model 3. Okay, done. Shortage is also there. Then finite replenishment rate is also there. So both are happening. So these are the formula for that value. Now let's say we have to find out what? We have to find out the Q dash. This is what? Maximum inventory level. And this is quite amazing result we are going to get here. Q dash is what? P minus C upon P QE minus S. Please remember this result. Please remember this result. This is very, very important. SD mastermind, bilkul exactly that answer was 20. But this is the way you are going to find out the maximum inventory level in the system. And what is that value? This is 1 by 2. This is come out 1 by 2. Okay. And what is QE? 4919 minus 20. Just please solve it and you will get the correct answer. You will get the correct answer. Okay. 4919 divided by 2 and minus 20. You will get approximately, you are getting 2439.5 units. This is the correct answer. Okay, so if you check that all the questions which I am discussing with you, it is having the capability, means they are having the probability that come in the coming examination, gate examination, as well as they are quite tricky. Tricky means what? You see, most of the people are not, they don't know that how to find out the Q dash. This is the value. This is what? Maximum inventory level. They can find out. See, many of the people can find out the value of QE for this model, but they will not be aware that how to find out the value of Q dash, maximum inventory level. It's quite interesting also. Okay, done. So keep this in short notes, keep this in short notes, and today itself you have to revise all the concepts before going to the sleep. Okay, now come to the next question. Yes, here this is the this is what? From transportation. Let us see, this is there is no trick here in the transportation, but at last I am going to discuss a very excellent trick here. Very excellent trick here. Okay, you give me one answer. Suppose here we are having transportation cost 3 rupees, here 11 rupees, here 7 rupees, here 6 rupees. Okay, some quantities filled here 30. Okay, some quantities filled here, and some quantities, okay, let me take this as 8. Excellent shortcut trick I am going to discuss here. Anyhow, can it be a potential cell? Can it be a potential cell? Do you remember what is the potential cell? The potential cells, whether, see, should I transfer some quantity here or not? I'm just asking that part. Okay, now just check. So some people will be checking the ui plus vj equals to cij. First, from filled cells they will be finding out the ui plus vj minus cij equal to cij. For unfilled cells they are going to see. For filled cells, what you are doing? For filled cells you are doing this, and you are finding out the value of u and v. Then for unfilled cells, what you are doing? ui plus vj minus cij. You are doing that part. This part you are doing. Okay, I am saying that I am going to tell you the trick that it is not needed. It is not needed in gate examination. I can give the 100% guarantee. I am not going to check whether we are having the potential cell. I am not going to check what is the ui plus vj minus cij for let's say unfilled cell, because it is a very time consuming task. So I am going to give you the very excellent trick. Okay, first of all, just check. If suppose I am just asking without check, I am just asking, this is the potential cell. Will you believe this or not? I am saying this is the potential cell. Will you believe this or not? I am telling you, you are not going to believe. Why? If suppose this is coming out as potential cell, you are going to shift the quantity here. And if you are shifting some quantity here, you have to shift some quantity from this side. Are you getting this point or not? If you suppose this is coming out as potential cell, are you going to some quantity shift from here to here? Yes, sir. And if you are shifting some quantity here, you just to make the balance, you have to shift some quantity from here to here. Agreed or not? SD, mastermind, are you agree with this point or not, beta? Please tell me. This is your basic feasible solution. Now I am checking the Modi's method. I am checking. Suppose Modi method I am checking, or let's say degeneracy I am checking. Okay, what I am saying, Just think of, if you shift this quantity here, what is the additional expenditure? What is the additional expenditure? Just think of. Tell me, what is the additional expenditure? Sir, the expenditure per unit is 3 rupees. Right now you are transporting the unit 3 rupees per unit. If you shift the quantity from here to here, the transportation cost will become 6 rupees. So 3 rupees per unit will be the extra charge. Extra charge. Okay. And when you are shifting this to this, how much money you can save? How much money you can save by shifting this quantity to this quantity? How much money you can save? Here you have to spend 3 rupees more per unit. And if you are shifting this quantity to this place, you can save 1 rupee. Only 1 rupee. Are you going to shift the quantity? Are you going to shift the quantity? Arey, ye UI plus VJ is not required, yaar. Because in GATE examination, maximum to maximum, they are going to give you the matrix of 3 cross 3. This is required when I am having the 4 cross 3, 4 cross 4 matrix. Then it is required. In 3 up to 3 cross 3, this UI plus VJ is bakwas. Just nothing or not of any use. I am not going to shift any quantity here, beta. Not. Okay. Just I am going to discuss this kind of trick in the next question. Next question. Okay. So, but just by seeing the data, you can say, yes, sir, it is quite, yeah, interesting. It is really interesting that how we can easily find out, the optimal answer. Okay. So now you and me both are going to enjoy the question. See, this is the what? This is the plant. We are having the warehouse here. Supply capacity is also given. Okay, supply capacity. What is the supply capacity? Let us check. The supply capacity is 60 or not here. 60, 70 and 80. 60, 70 and 80. Okay. What is the demand, beta? What is the demand here? What is the demand? The demand is what? The demand of the warehouse is also given. 50, 80 and 80. Now you have to check two things. Before proceed, you have to check two things. Whether the total supply equals to total demand. Yes, sir, the total demand is equals to total supply. How come? 60, 70 this is how much? 210. This is also what? 210. So this is okay. And one more thing you have to check, whether the data, whatever the problem is given, is this minimization problem or maximization problem. Please remember that if you are not checking this, I told you in my lecture that you have to check this very carefully, whether this is minimization or maximization. If suppose this is maximization problem, then we have to take one step more, which already I have discussed in the lecture. But now if you check right now, let us check whether minimization or maximization. Here the unit cost is given. Cost. And whenever the picture is given in cost, the thing is what? We have to minimize the cost. Minimize the cost. Please remember. So it's very clear the objective of this problem is what? Minimization. Yes, the problem is what? This is from minimization objective. Okay. Now let us solve this. And the thing I told you, I am going to use that without applying UI plus VJ. I am not going to apply the UI plus VJ, and you are going to enjoy that concept. Okay. See this. See. So what I will do, first I will find out the, let us use VAM. I always prefer VAM, beta. Use VAM to get the feasible answer. We have to find out the optimal solution. But before getting the optimal, we have to find out what? We have to find out the VAM method. VAM, okay. VAM we have to apply, okay. So what is the first step? The objective is minimization. Let us find out the penalties now. Let us find out the penalties. Okay. So what is that? Penalty. Done. So let me give you some values of penalties here. Okay. The penalty is what here? The cost. Can you tell me the penalty of first row? Can you tell me the penalty of first row, beta? The difference of two least values. The difference of two least values. Yeah, is this? Please check. just dropping one message beta, just a minute. Yes, yes, what is the penalty? Yes, 4, 7 and 3, this is penalty 4. The next one is 5, the next one is 2, the next penalty, the difference of least two values 5, the penalty is 5, the penalty is 3 and 7 4, and the penalty is 3 and 5 2. These are the penalties. Okay, 5. So where is the maximum penalty? The maximum penalty is 5 and 5. Enter into the, see, wherever you are getting the maximum penalty, enter into that row and enter into that column, and wherever you are finding out what, wherever you are finding the least cost, start your purchase activity from there. Start your purchase activity from there. Clear? Yes, the penalties are 5 4 2 and 4 5 2. Exactly, mastermind. What is going to happen here? See, so where we are going to, we are interested. Here is the maximum penalty. Enter into that. Where is the least cost? The least cost is 3. Okay. Where is the maximum penalty? 5. Enter into that column. Enter into that column. 3. Oh wow, same. So I am going to start the transportation from here. I am going to start the transportation from this value. This. Can you tell me how much quantity I can transport from here? How much quantity I can transport from here? Can anybody tell me? 50 is the demand, 70 is the supply, 70 is the supply. So definitely what I am going to do is 50, the least one. 50 is the demand, 70 is the supply. So 50 is what? 50 is my area of interest, the least value out of these two, least value. Okay. So when you are putting the 50, cross it. Why? Because nothing, the demand of A has been fulfilled. Put the 0 here and make this 70 as what? Make this 70 as 20. Make this 70 as 20. Now go for the next part. Go for the next part. Next. Okay. Now next penalty. This is over now because demand has been fulfilled for A. So it is not going to purchase any quantity from X and Z. Now what is the penalty? Again 4. What is the penalty? 1. What is the penalty? 2. New penalties. What is the penalty here? 4. What is the penalty here? 2. Again there is a tie between maximum penalties. Here the maximum penalty is 4. Here the maximum penalty is 4. If you go into that row, 3 is the least cost. If you go into that row, 3 is also the least cost. Oh, what is happening? Maximum penalty got tie, as well as the least cost also got tie. What is your step? Tell me, what is your decision now? When maximum penalty is getting tie, as well as the minimum cost is also getting tie, please remember, out of these two cells, select that cell. Tell me, out of these two cells, select that cell. Which cell you are going to select? Tell me, which cell in which maximum quantity, yes, maximum quantity can be accommodated. Exactly. Excellent beta, excellent, very good. Okay, so if you check how much quantity I can accommodate here, 80 is the demand, 60 is the supply, so only 60. And how much quantity I can accommodate here? 80 is the demand, 80 is the supply. So where you can make a more quantity, definitely you are going to start the accommodation from that cell only. And what is going to happen here? You are going to put 80 here, 80. Okay, and when you are putting 80 here, cross it, it will become 0, and cross this also because it has become 0. Now we are having only two cells, and the quantity is remaining, whatever quantity is remaining, put in that only. So 60 is here and 20 is here. Okay, so it will become 0, and this 80 will become 0 because 60 plus 20, 80, the demand has been fulfilled. What is the total cost? Can you tell me, beta? What is the total cost of accommodation, of the transportation here? Let us find out what is the total cost. Here is the total cost by VAM. What is that? This is 150 plus 240 plus 180, 180 and plus 180. So if you check that 260, is this 750? Okay. Okay, Kalyan. Sure. See, 150, 240. I'll take. See, if you want a session for the PYQs, I'll go for that. No issues. Okay. Done. See this. I'll make a separate. I'll request the. I'll request to schedule a. Even what is it? I'll tell the people to schedule a class where I am going to discuss only the PYQs of PI, only PI. Okay, done. What is that? This is how much this value coming out, beta? 750. 750. Now see how the people are going to waste the time in UI plus VJ. We are not going to waste the time. See how. Let me make a copy of this. Let me make a copy of this. Okay. I'll be deleting this part. Let me delete this. So 750, we have what? We got the answer. We got the answer of 750. Let me delete this also. It is not required. This also. Now see this. How fast I can check that. Please check whether there is a degeneracy. है ना? I'll take beta PI, है ना? I'll take a separate class for PI. Please tell me where is this degenerate solution or non-degenerate solution? Can you answer it? Whether this is degenerate solution or non-degenerate solution. SD mastermind, can you answer it, beta? Can you answer it? Please check. Degenerate. This is degenerate solution, bache. Degenerate. See, this can be asked in the. They can ask this also. That the answer you are getting from them, whether this is degenerate or non-degenerate. Let me tell you with that thing. Let me tell you that thing in this. Okay, here only. Okay. What is m plus n minus 1? 3 rows, 3 columns, minus 1 equals to 5. How many filled cells you are having? How many filled cells you are having? You are having only 4 filled cells. Only 4 filled cells, beta. Okay. So it means your number of filled cells, occupied cells are less than the m plus n minus 1. So please remember, number of, let me write down, number of occupied cells. Number of occupied cells is what? Less than 5. So what is that? Degenerate solution. Degenerate solution. So I cannot go for the Modi's method. I cannot go for the Modi's method. And in that case, just think of, should I put some epsilon quantity somewhere? Where should I, just to remove the degeneracy, just to remove the I will not use UI plus VJ concept. I will give you the fast trick. Okay. Just first of all, just help me in that case. Where should I put the small quantity epsilon? Can you help me out in that case? Where should I put that? Sir, obvious, the unfilled least cost cell. Where? The unfilled least cost cell. And where it is? Where is the unfilled least cost cell? That is here. That is here. Where? This is 8, 8, 5, here. So put the epsilon quantity. So now this is also filled cell. Now this is also filled cell, beta. Filled cell. Okay. Clear? Now this is non-degenerate. Why you are checking for the UI plus VJ minus CIJ? Okay, let me tell you one thing. How fast I can check that whether there is a potential cell or not? Should I tell you? See this. See. If suppose you are taking this as potential cell. Suppose you are taking this as potential cell. If this is the potential cell, you are going to make a square loop. I am not saying square loop. You are going to make a closed loop. Are you going to make a closed loop with a horizontal or vertical lines or not? Yes, sir. I am going to make a horizontal and vertical. I am going to use the horizontal and vertical lines, and I am going to make a closed loop. Are you getting this point? Okay, make a closed loop. Where if suppose this is the potential cell, Okay. Do you think 11 rupees can be the potential sell? Okay. Let me make the loop. Let me make the loop. See, you have to take the turn from the filled to filled cell only. Filled to filled. So this is also filled. That's why I have taken turn. This is also filled. That's why I have taken turn. This is also filled. I have taken turn. I have taken turn. Are you getting this point or not? Just think of. If you shift this quantity, here, is there any saving? Is there any saving? Yes. Yes, there is a saving. I'll tell you how. This 20 will come here. See, oh, okay, here there is a minus only. There is a minus. Just check off. If you shift the quantity here from 3 to 11, are you going to shift this quantity? Is this possible? Are you going to get any profit? Are you going to get any profit? And you know how you are going to check that? I'll tell you, and this is quite easy and you are going to really enjoy it. Tell me, whatever cells you are using right now, what is the sum of the per unit cost? What is the sum of per unit cost? This is really excellent technique. What is the sum of per unit cost? 12 rupees. This is filled. So you are using this cell, and right now the sum of the cost is 12 rupees. And the cells which you are not using in the loop, what is the sum of that? Can you check it? I am just giving a very easy. So the cells you are using, the sum is 12. The cells you are not using, the sum is what? 16. I am not going to transfer the quantity. I am not, because whatever cells I am using right now, my expenditure is only 12 rupees. Are you getting this point or not? See, suppose 16. Suppose I am taking, let's say, I am not taking this as filled. I am taking this as potential cell. Suppose this is potential cell. So let me make a loop of filled to filled. This, and this. You can see the loop. Here the quantity is filled, here the quantity is filled, here the quantity is filled. Are you getting this point or not? Now, if just think of what is going to happen. If suppose you transfer, see this, cross check. We have to check in cross. Are you getting this point? What is the cost of this cross? Tell me. See, if you are going to shift the quantity from here to here, some quantity will be transferred from here to here. Okay, now see this, very easy. You transfer the quantity from here to here. First of all, your cost will be increased. Clearly you can see the cost will be increased. And when you are going to transfer the quantity from here to here, again the cost will be increased. Just check off. If you transfer the quantity from here to here, yet the 3 rupees will become 8 rupees. And when you transfer the quantity from here to here, ultimately if you transfer the quantity from here to here, then you have to transfer the quantity from here to here just to make the balance. Are you getting this point or not? See, this is just a common sense. Whether I am getting the benefit or not. So now you can say, sir, okay, but how many times we have to check, sir? For every cell we have to check. If suppose this is potential, then what is the impact? No other cell. See this. See, I'm just giving a very excellent idea. Just think of. If you take this as potential cell, let's say, if you take this as potential cell, okay, now again you check 3 to 7, 3 to 5. If you transfer the quantity from here to here, you are transferring from 3 to 7, 3 to 5. Not recommended. Beta, are you getting the idea that how I am checking that? Are you getting somewhat idea? And this, see, whether you are getting the complete picture or not, leave that. My funda is going to work in gate 100%. 100% it is going to work. 100% it is going to work, beta. Are you getting this idea? That why you are calculating the ui plus vj minus cij? Why? Because there is a too much of it requires too much of time. It is going to consume, and there is a chance to have the mistake also. It's quite easy, quite easy. Simply you can check whether I am getting the benefit or not. Quantum mechanics में problem है. That is not my part बेटा हर्षित, है ना. Now see this, see, है ना, quantum mechanics में problem है तो नहीं, actually it is not assigned to me, so definitely, है ना, you can discuss this problem with the concerned people, concerned teacher. Definitely the every teacher is dedicated and they are going to help you out. Okay, so just apply your logic beta, just apply your logic, just do the practice like that. Okay, and definitely it is going to work 100%. Okay, I am 9 times, not 9 times, 8 times. I am 8 times gate topper. Gate topper means what? Rank 1, rank 42, 62, 65, 206. No. I have given 9 times gate. Only one time I got the rank, very poor rank of 4293. 4293 was my poor rank. Okay, otherwise around 6 times I got the rank below 200. है ना. So I am using these techniques. I am not saying that you use this. I am having the perfection over these techniques. Okay, done. See this. See. With in this in PI my best rank is 1, and in gate my best rank is 62, 45 also, 45 in mechanical, है ना. Okay, so I am having a good experience. I know that what kind of techniques we can use in the gate, and we can save the time. This is, see, examination is also the matter of saving time. The time management is equally important as the knowledge important is. Done. See this. See, so you are going to use this technique, and you can say this is, see, 750 is the optimal answer only. You can simply say, see, if I go back and simply I can say, what is that? This is optimal answer is what? Optimal answer is VAM only, and that is 750 rupees. There I told you how to use the shortcut trick. Here I am going to tell you, don't use the shortcut trick. Don't use the shortcut trick, because you are going to do the blunders if you are going to use the shortcut tricks. Please mind my words. That's why I put, see, this is the question, very easy question from the assignment, but just of the greed, just because of the greed that I can save time. Okay, tell me, for machine 2, what is your first choice? These are the machines, these are the places. You can see locations are given, these are the places, these are the machines. These machines are going to can work over these 5 places. Different machines can work over 5. Can you give me your first choice for M2? First or second choice? 2 choices. Just you are having the greed. Oh wow, 1, 2, so much, so less time. This is what? Cost. So less cost. What is your first choice or second choice? P1 or P5. And please remember, out of 4 options, 3 options, the gate is going to put P1 and P2 only, P5 only. P1 and P5 only. Now solve this question, and I bet on this that you are not going to, if you are go by the logic, the M2 will not be placed at place 1 and place 5. The answer will not come out this, the answer will not come out this. So don't use the shortcut tricks just by seeing the data. बिल्कुल करो बेटा, बिल्कुल. सेकेंड ईयर से जो तैयारी करना शुरू करेगा उसको तो मजा ही आ जाएगा. चलो करके दिखाओ, चलो इसको करके दिखाओ. ठीक है, यहां करके दिखाओ. अब इसको करके देखें जरा. ठीक है, चेक करते हैं कि how easily we can solve this question. How easily we can solve this question. See, first of all, make a box here. Make a box here, beta. Okay, no need to do like this. So, okay, let me do the row relativity. RR. Don't go by the faster method, beta. In this case, wherever the teacher are suggesting you use this technique, just apply the technique there only. Where we are saying don't apply the shortcut trick, so please don't apply there. Okay, clear? Because many of the people are going to do the mistake. They are just seeing 1 and 2 and they are just putting the answer M2P1 or M2P5. Okay, now see this. The least value is 10. The least value is what? 10. So here is 10. What I will do, 5 0 5 0 15 15 and 0. The next one 1 0 7 9 19 and 1. Okay, I'm just subtracting the least value of each row from all the values of that particular row. So this is the least value, subtract this value from this. This is the least value, subtract this value from this. Okay, like that. Okay, so subtract the least value of each row from the all values of that corresponding row. Okay, so this one here, what is the least value, beta? 8. So 8 is what? 0 1 9 12 and what? 2. Come to the next one. This is what? 10. 10 is what? 4 0 15 17 and 5. And the last one 8. So this is 2 0 17 19 and 4. This is what? Row relativity. Harshit, this is what? Row relativity. Now come to what? Come to column relativity. Column relativity. Same thing I am going to do for the column also. The columns already having 0, they are not going to change. So the first column, the second and the last column, the value will remain same. So let me write down those values first. 4 2 0 7 1 0 0. Here the least value is 9. So 6 0 10. Oh, not 10. 0 6 and 8. Here the least value is 12. So the 12 is 3 and 7. If I am doing any calculation mistake, you can please suggest me, sir, there is a mistake, I'll correct it. Okay, and this is 0 1 2 5 or 4. What is the next step? Okay, tell me how many lines you require to cover all the zeros. I hope that you are clear with the obvious. This is only for those people which are already clear with the basics. Okay, so tell me how many lines you require to complete to cover all the zeros. To cover all the zeros, how many lines? Minimum lines. Please remember, we have to identify the minimum number of lines. We have to cover all the zeros through the horizontal or vertical line combination, but those lines must be minimum in count. And what is that value? That value is what? That value is I think we can do that in 4 lines. 1 2 3 and 4. 4 lines. In 4 lines I can do this part. Clear? Okay, so if suppose I can cover, so this is optimal matrix. No, the order of this matrix is 5 cross 5. So until I am not getting the 5 lines, I can say that this is not the optimal matrix. So minimum number of lines must come out 5, then only I can go for the assignment. So I'm going to make the copy of this again. I'm just making the copy of this. Okay, and in the copy, I'll delete this. I will delete this part. Okay, so let me come back. Now here. What is the next step? If you are not getting the optimal matrix, what you can do is you can subtract the value which is not lying on the lines. Where is the least value which is not lying on the lines? This is 2. This 2 is to be added at all the intersections. and it is to be subtracted from all the values which are not lying on the lines drawn, which are not lying on the lines. So this 2 is to be subtracted from all the values which are not lying on the lines drawn, and it is to be added at the intersections. Okay, so let me do it fast. This 2 6 3 0, I have added at the intersection. This intersection will become 9, this will become 3, these value will remain same, 0 7 1 0 0 2 and 0 0, these values, and the remaining values we have to subtract this 2. So 2 0 4 6 3 5 3 2, 3 5 and 3 2. Now again draw the lines and check whether you are getting the minimum 5 lines or not. Okay, from your side you cannot draw the minimum 5 lines. You whatever lines, minimum lines are required, here just you try to cover all the zeros by that. If suppose they are coming out 5, means with the equal to the order of the matrix, it means you are at what, 3 lines. Harshit, can you cover in 3 lines? Please check, beta. Harshit, if you can cover this, because I need 5 lines here. Harshit, I need 5 lines here to cover all the zeros. Please check. Should I show you? 1 line. Suppose 2 lines. Suppose 3 lines. 4 lines and 5 lines. I need 5 lines, beta. I cannot cover in 3 lines. Just check. Minimum 5 lines are required now. In this case 4 lines was required, so that's why I can say this is what, non-optimal matrix. This is what, non-optimal matrix. But here I can say this is what, optimal matrix. What is that? Optimal matrix. Okay, so that's why, Harshit, I am saying that you cannot cover all the zeros in 3 lines. Minimum to minimum 5 lines are required. If you can do so, it's really a magical thing for me if you can do so. Okay, so now this is what, optimal matrix, because the number of lines are what, 5. So let us go to what, let us go to the assignment, and we have to do the assignment from all rows or columns which are having single, because 0 is the indication of minimum cost or minimum price. So wherever you are having the minimum cost, okay, minimum zeros, you are getting the single 0, you can start the assignment from that place. Okay, because there is no confusion at all. Okay, so in this row, this is what, single 0. In this row also we are having single 0. Now this is 2 zeros, 2 zeros, 2 zeros. Acha, because you have assigned this 0, 1-to-1 mapping, cross this 0, cross it. Now the last row having single 0. Now when you are using this, you cannot use these 2 zeros. Cross it, beta. Cross it completely. Okay. Now you can see this is also having single 0. This is also having, oh, when you are using this 0, cross this 0. Now you are having single 0. So this is the final assignment. You are starting from those rows and columns which are having single zeros, and by 1-to-1 mapping, because one person can be assigned to one machine and one machine can be assigned to one person. Okay, that's why the other zeros coming to that particular row or column, you have to cross it, you have to eliminate that. Okay, though 2 people cannot work on a same machine, or 2 machines cannot be given to one place. Okay, so from here you can plot the same thing here, 10 20 10 and 10. Now you will be feeling, you will feel surprised that sir, 1 and 2 is, why 1 and 2 has not been taken? Can you answer it, that why this 1 and 2 is not coming in the picture, having the so low cost, even though they are not coming? Because if I will use this one, the other place cost will be increasing so high. Okay, because if you are using this one, you cannot use this 10. So other places will increase the cost. Okay, so that's why this 1 and 2 is not being covered. So we have done the, what is the, find the minimum total cost through assignment. So what is the minimum total cost? Minimum. What is the minimum total cost? This is the cost matrix. So 10 plus 10 plus 10 plus 10 and 20. This is 60 rupees. 60 rupees is the total cost in this case. Clear everyone? Okay, done. So now come to the next question. Come to the next question, beta. Few more questions are there in this discussion. Excellent questions we are having here. See this. Now there is a question again, the excellent question, which says that we are producing something. We are producing something, okay. And in that production, every quantity requires 15 rupees. So in a day, I am producing 1000 units. 1000 units, okay. The production cost per item is rupees 15. See whether that will be defective or non-defective. First of all, I will be giving. I have purchased the raw material. I put that on the machine, and total cost to produce the final item is 15 rupees. The production cost is 15 rupees, okay, including material cost, you can say. Now what is happening? Out of those 1000 items, the 75% items are what? The 75% items are conform to the specification, means they are non-defective. Conform to a specification means what? Whatever specification was required, we are confirming that. So these are what? 75% are non-defective. Non-defective, okay. And 60% of defective. Non-conforming means what? Conforming means non-defective, and this is what? Defective. This is what? Defective. Non-conforming means defective, okay. 60% of defective are can be reworked. Can be reworked means what? Some items, see, there are two categories of defective. One, this is defective, but I can do some rework and I can make it useful. This is one category of defective. Another category of defective is scrap, means that is that much defective that I cannot do anything. I have to throw it in waste, okay. So it means suppose like that. What is rework and what is let's say completely scrap? I'll give you a very practical example. Suppose my mother has prepared a dish, two dishes my mother has prepared. One is having a very low amount of salt. It is not having any taste, very low amount of salt. And the another one is having a very high amount of salt. You can see that what is going to happen. The vegetable which is having the low amount of salt we can put some more salt in that and it can be useful. It means what? That is reworked, capable to rework. But if suppose we are having that much another kind of dish which is having a lot of amount, 5 times amount of salt, I cannot do something else to that, okay. It is what? It is going to, I have to throw it in dustbin, okay. So what is that? That is the high amount of salt is what? Scrapped, and the low amount of salt is what? That is also defective. Both are defective, but one can be utilized by taking some step. That's why we can call this as reworked, okay. So I am going to make the chart for this. Whatever data they have given, okay. So see this. So case 1, they have given 2 cases. Case 1, I am preparing 1000 units. 1000 units. Out of this, 75% non-defective and remaining 250 are defective. Okay, out of this 60% means what? 150. 60%. 150 can be what? Reworked. But the remaining 60% of that can be reworked, and the rest are what? Scrap. Rest are what? Scrap. So I have to throw it in dustbin only, okay. Done. So let us find out the cost of this, okay. So let me show you the data also. Every unit, whether you are producing defective, non-defective, okay, you are wasting the Latin means what? That dal you are going to waste, okay, whether it is having the low salt or high salt, okay. So the preparation cost of any kind of dal, that is what? 15 rupees. But if suppose it is defective and comes under rework category, again I can additionally spend 5 rupees. 5 rupees can be spent additionally and it can make useful. But the remaining is what? The rest 40% is what? Non-conforming items, and these are what? Scrapped, means we have to throw them. Okay. So here, what is the total cost? See, what is the total cost? Total cost 1000 units into 15 rupees, because every unit we are preparing on the machine, whether they are coming as defective or non-defective, after that, these rework units, the units which can be reworked, 150 units are there which can be reworked, and what is that? 5 rupees per unit we have to spend additionally. And the scrap which we have produced, it is not of any use. I am not going to invest, I am not going to waste my money to put it as additional. Okay, so what is going to happen here? This is 15,000 and what? 750. So the total amount I spent on this is what? 15,750 rupees. But after doing so, just check that how many items I can eat. How much item I can eat, suppose. Okay, so definitely, if suppose this is the eatable, these are non-defective, so definitely I can eat this. This was also this was defective, but I put some additional salt and now I can eat it. But this is scrap because it is having too much of salt and I am going to throw it out. So how many items are useful to me? If you check, the useful number of items are 750 and 150 only. Two, okay, two categories. These are useful and these are useful. These are not useful. Okay, so per unit cost, if I ask you per unit cost, what is that per unit cost? This is 15750 divided by what? 900. It will come out 7.5 rupees. 7.5 rupees. Okay, now they are saying in the same question, they are saying that some process improvement after implementing the process control. After implementing the process control, now we are having some good control over the machines, okay, over the production process, and now 80% items are non-defective. Okay, so and 60% defective can be reworked. So come to the second case. And let us discuss that. Case 2. How many items we are having? 1000 units. How many items we are having? 1000 units. Okay, out of those 1000 units, case 2 is what? After process improvement, 80% are non-defective, so obvious 200 are defective, and out of this 200, 60% are reworked, and what? This is 80 units are what? 80 units are, let's say, scrapped, waste, completely waste. Okay, now what is the total cost? We have to find out the per unit cost. So योगेश, मैं बढ़िया हूँ यार, बहुत अच्छा हूँ, ठीक है, बहुत जल्दी आपको फिर से मिलूंगा, फिर से मिलते हैं, ठीक है। ये देखो जरा ध्यान से, है ना, मैं भी मिस करता हूँ आप लोगों को, मैं भी बहुत मिस करता हूँ, ठीक है ना, आई एम ऑल्सो मिसिंग यू। 15 rupees, okay, plus now I can say 120 rupees or what? 120 rupees are reworked, beta, reworked. So 5. So we can say how much money is required here. This is 15,600. 15,600 rupees. Okay. So per unit cost. If you check per unit cost, what is that value, beta? This is useful item. This is also useful item. So total cost is this, and divide by number of useful items. So number of useful items are what? 920. Let me check that how much value we are getting. The people are missing my stories, huh? Again, I'll be coming with the new stories, beta. So this is what? 600. Obvious. The complete lecture which I have taken on this part, that was completely covered with the stories only. 16.95 or something, this per unit cost. Okay. बिल्कुल मिलेंगे, है ना योगेश, definitely we are going to meet. So in this case, if you check, initially before process improvement, this was the cost, and the case 2, this is after process improvement. The number of defectives are less, scrap is also less. So where is the correct answer? Let us check. Yes, initially the case 1 and the case 2 is this one. The answer is A. The answer is what? A. Got it? Now come to the what? Come to the next question, beta. Come to the next question. This is what? Find expected time to complete project and its standard deviation. Okay. So first of all, they are asking for the expected time. Obvious, as you know, what is the value of T, beta? The value of T, the expected time for every activity is what? TP plus 4TM plus TO divided by what? Divided by 6. So we have to calculate this as well as for the variance of the activity. This is what? TP minus TO by 6 whole square. So these two values we have to find out, but please remember this is to be calculated on the basis of critical path only. So first of all, find out the value of T and calculate the critical path. And now you can use my easy technique. No need to use this formula, beta. No need to use this formula. There is an excellent technique behind it. Just check. The difference of TM from TO and TP both are same. Just check. The difference of TM with TO and TP, the difference of these two and the difference of these two, is it same? Yes sir, it is same. Yes, 2 minus 1, 3 minus 2, the difference is same. Whenever the TM is at equal distance from TP and TO, whenever TM is at equal distance from TP and TO, no need to apply the formula. Whether you apply the formula or not, directly you can, the value of T is equals to TM. You can apply the formula, but I am not going to apply because I know that whenever the TM is at equal distance from TP and TO, then the T is what? T equals to TM only TM. Okay, so see this, how fast I can calculate. 2 equal distance 6 equal distance 5 and equal distance, see 7 is equal distance from here and here also, 7 equal distance 4. And please, in gate also you can apply this technique. This is really beautiful. Okay, this is what? 5, this is 6 and this is 3. You can save your 1 minute by applying my technique. You can save 1 minute by using my technique. Are you getting this point or not? Okay, done. So here you can see we are getting the value of T. Now check this. Let me apply this. Let me draw the diagram. 1, 2, 3, 4, 1, 2, 3, 4, 2 to 5, 3 to 5, 2 to 5, 2 to 5, 3 to 5, 5 to 6, 4 to 7, okay, 5 to 6, okay, 5 to 6, 5 to 6, 4 to 7 and 6 to 7, 4 to 7 and 6 to 7. Four to 7 and 6 to 7. Now we can apply the T. T is what? 2, 6, 5, 2 to 5, 7, 3 to 5, 4, and 4 to 7, 6, then 5 to 6, 5, and what is that? 6 to 7, 3. Okay. So where is the critical path? Can you identify that? The critical path is this only. The critical path is, the critical path is this only. Please check. 1, 2, 2, 5, 1, 3, 1, 4, 5, 6, okay, 4, 7 and 6, 7. Yes, this is what? This is critical path. So if you check this is critical path, so definitely the expected time to complete the project, expected time to complete Project expected time to complete. This is 10 and 18. This is 18 days. 18 days. Oh, where it days? Where it has gone? It's magic. 18 days. Now they are asking for the project standard deviation. Please remember the project standard deviation. Let's say this is project. This is what? This is under root summation of variance of critical path activities. What is critical path activities? Please remember that. So what we are going to do here, let us find out the critical path activities. 1 3, then 3 5, then 5 6 and 6 7. So I'm just going to take what? I'm just going to take only 4 values. So TP minus TO, this is 2 by 6, 2 by 6, this is 1 by 3 and square 1 by 9. Here also this is 4, TP minus TO 4, 4 by 6 is 2 by 3, 2 by 3 and square, this is 4 by 9. 4 by 9 plus this is 1 by 9. Only for the critical activities we are going to discuss, and this is 1, this is 2 and this is again 1 by 9. Again 1 by 9. So what we are getting is, this is 7 by 9 root. 7 by 9 and what? Root. These many days. We can say these many days. Okay. So here what is, okay, this is what? This part is done here. 7 by 9. You can take the answer in decimal. Now let us go to the next part, which is very important. It is not covered in the lectures, but probable. It is probable to come. Least probable, but probable. Now this is the question from the reliability. Okay, when the elements, components of a system are connected in series or parallel. Let me give you the basic formulas for that. Let me give you the basic formulas for the same. This is, let's say, a reliability. Okay. Suppose we are having the 3 elements in connected. Let's say, what is reliability? The reliability is probability of non-failure. What is that? Probability of non-failure of the system. Non-failure means the system is not going to fail. So please remember, when the 3 components are, this is the whole system of 3 components. The component 1 is having reliability 1, this is 2 and this is 3. So please remember, if anyone fails, the system is going to fail. So everyone has to work if system has to work. Okay, everyone has to work for when system has to work. And in that case, if you check the reliability, see, if the reliability of the system, we can say this is what? This is the whole system. This is what, beta? This is whole system. This is what? System. Okay, done. So what is that? The real, this is what? R1 cross R2 and cross R3. Please remember that. Okay, R1 cross R2 cross R3. Done. Now if suppose the things are connected in parallel, ye ho gaya in series. This is what? In series, and this is what? In parallel. Okay, so when they are connected in parallel, definitely what is the choice for us? What is the formula? Let's say R1, R2 and R3. Okay, this is what? R1, this is R2, and what is that? R3. Let's go by that with that way. Okay, so in this case, please remember reliability of system. This is very, very interesting formula. Okay, 1 minus R1, 1 minus R1 into 1 minus R2, 1 minus R2 and 1 minus R3. This is the formula for what? Reliability in system. Clear? So now you can come to this place. This is 0.9, 0.7, 0.8, 0.7, 0.8. Now these are what? These are connected in series. So this is R1 and R2. It will become 0.56. This is again R1 and R2. This will become what? 0.56. Now this part and this part are in parallel. This part and this part are in parallel. So for these two. I'll be taking this in series later. I'll be take care of this later. But first of all, let me solve this in series, this in series. So this is the answer. And now let me go for the parallel combination. Parallel combination. Okay. So what is that parallel combination part? The parallel combination part is what? Let's say this is 1 minus 1.56, 1 minus 0.56, and if you solve this, this is 1 minus 0.44 square, 0.44 square, and it will come out. Let me calculate that part. Let me calculate that part. 0.44 square, 1 minus answer. This is 0.8064. Now you can see this is the answer for this much only. See, this is the answer for this much only. Okay. Now this is again in series. So our system is what? 0.9 into 0.8064 equals to what? Let me calculate that. This is 0.7257 or something. Okay, like that only. Clear? So I hope you are clear with this point, that you are having the what? You are having the reliability concept now. No need to go into the depth. You are simply remember these formula for parallel and for series. That's all. Okay. Now come to the next question, beta. Yes, this is very important. Very important here. Let's say we are having the what? List 1, which is having some inventory control systems. Do you remember ABC? This is vital, essential and desirable. Vital, essential. Vital means what? The item is so critical that without which the system cannot work. What is the vital item? The item is so critical that without which the system cannot work. Now listen this and match the following. VD what? Criticality. VD is work on the criticality. If you remember ABC, I told you that in ABC we are having what kind of let's say explanation. In ABC we are having the annual usage. See, it doesn't matter whether you are purchasing the engine or let's say nut and bolts. Suppose you are purchasing one engine in a year and it cost for 1 lakh rupee, and here the nut and bolt, one nut and bolt is for 5 rupees only, but over a year you purchased a 5 crore worth nut and bolt. 5 crore worth nut and bolt. Please remember, the nut and bolt will come under high cost category, A category, and the engine, which is only purchased once in a year, very low amount in a year has been expended on that engine, it goes to C category. So please remember, we are not going to take the ABC category on the basis of the item cost. It is the annual usage cost. In a 1 year, how much expenditure is occurring on that particular item. If the cost is annual usage cost is very high, definitely we are going to put that item in the what? In the category A. So ABC is what? Oh no, ABC is what? Annual usage. Okay. SDE. What is SDE? Is scarce, very difficult to found, difficult and easily available. Easy available. This is the full form of SDE. Scarce, very difficult to found. This is difficult and easy available. So definitely this is what? A. So where is the last one? The last one is what? The last one is F and rate. Fast moving, normal moving, slow moving, fast moving. See this: fast moving, normal moving, slow moving and dead. Dead means what? Which is not going to move. Which is not going to move. I hope that you are clear with this concept. And now if you go by that way, we can see that ABC is what? ABC is the ABC. This is the answer. You can calculate that and you can see that this is the answer. Clear everyone? Okay. So obvious, this was the picture of the inventory which we have covered. Now let us come to the next question from the forecasting. As you know that in the forecasting we can see that with the formula is what? The formula is what? For the next period forecast, FT plus 1, we can say FT and what? Plus alpha DT minus FT. So if you check this, let us check what they are asking for, the forecast for the March month. Okay, March month. And what they have given? They have given the demand of February. The forecast also of February, it means previous month data is given. So let me put the data here only. Forecast is 10275 plus alpha is the smoothing constant is also given 0.25. And what is that? This is D. D is 12,000 minus 10275. This is what forecast value. Now let us check that which option is going to meet with that. The which option is going to meet with that. Let us find out the value. $12,000 minus 275, okay, into 0.25 beta. This 431 plus 10275. This is coming out 10706. Is there any? Yes, we are having the correct option here. So this is the correct answer. Okay, so simple question, simple, but just for the revision you have to keep this mind that if March data is they are asking and Feb data is given, and please remember there is only and only one method which is called as exponential method, which can do the forecast on one period data. None of the other method is having that much of capability. If you check, just to do the forecast for the March month, you are using only one period data of Feb. Other methods, whether that is in a regression method, whether simple average, weighted average. See, this question may come in gate that which method can do the forecasting only on the basis of one period data. That is only one method, which is exponential smoothing method. Please remember this part. Okay, done. Now let us come to the next question. See this. Oh, additional part. Yes, see this. Here's the question from the simplex method. In simplex method, I told you that they will be giving some data to you. See, you can check here. See, not this. Some data is given here. In this data, they are asking, they are saying, sir, this is the initial table where we can say, see, this is Z row. This is what? Z row. We generally in lecture, I take this as at the top. Here they have given in the bottom. Z, and this is what? Z. Clear? They are saying, this is what? This is the first table. After some iterations, we are getting this table. Let me check whether this table is what? Whether this table is okay, this is Z here also. Not. This is what? Z row. Here is Z row and this is Z row. Whether this is optimal table or not, we have to check this part. So this is maximization problem. Actually, I think I missed one slide. This was the maximization problem. This is given maximization problem. So in maximization problem, how you are going to identify whether you have got the optimal answer or not? Okay, you have to check the Z row, and in Z row, if you are not getting any negative coefficient, you can say we have reached to the optimal answer. We have reached to the optimal answer. So this is what? This is, here is the negative coefficient, and this is first table. After some iterations, we are getting this table, and in Z row, nowhere we are having the negative coefficient. We can say this is optimal table. And when you decided this is optimal table, now you can check how many extra zeros it is having. See, first of all, S is the basic variable. This is what? Basic. So basic variable and basic variable, S row and S column, at intersection they are 1, and this 0 was expected. This 0 was expected from us. Okay, clear? Here Y also here, Y row and Y row. Y row and Y column at the intersection they are 1, but at see, this was expected, but X is, see, this is optimal table. In Z row, if you check, here is the extra 0. This X is not coming in the basic variable column. X is not coming in the basic variable column, and even though we are having in the optimal table, we are getting the extra 0 in Z row. In Z row, we are getting the extra 0, and this is the indication when you are having the extra 0 which was not expected in the Z row and optimal table has already been obtained. You can simply say that definitely this problem is having alternate solution. Alternate. Okay, if no extra 0, unique solution, and extra 0, alternate solution. So let us find out the correct option here. This is the unique solution. LP has an optimal solution, but it is not unique. Yes, it is not unique. It is not unique. We are having alternate solutions also. We can call this as alternate. We can call this as multiple, or we can call this as infinite solutions. Not infeasible. Okay, I'm just saying infinite solutions. Okay, so this is the way we have completed this part, extra zero or non-zero. So first of all, ensure whether you are having the optimal table or not, and if in the optimal table you are having the, let's say you are getting the extra zero, definitely you can say what? You can say you are getting the optimal alternate solution. Now come to this part. In this case, in this this is from scheduling. Okay, they have given some jobs and they have given the processing time also. Some inventory holding cost is being charged. If you check the holding cost of each item per day is what? K rupees. Each item per day is what? K rupees. Now what they are asking for, they are asking that if you want to minimize the total inventory cost, in what order you are going to schedule, you are going to perform the jobs. Okay, so here you can say whenever total inventory cost is to be minimized, to minimize, we can say we are going to follow what? We are going to follow what? SPT method. Please remember, inventory holding cost is to be minimized in the SPT method. This is very, very important statement. So let us check, let us apply the SPT. So first I am going to perform T is first, because this is the minimum processing time, shortest processing time, and P I am going to perform at last. This is last. Okay, so obvious, where is the option? Okay, here there is a tie. Okay, here is the option. Why? This is 1. Let me give you the values. This is 1, this is last 5th one, and this is 3, so this is 4th one. And this may vary, it may be 2 or it may be 2. Okay, so 2 or 3 may vary, but it will remain 4, and here we are having the correct option. So please remember, to minimize the inventory holding cost, we have to what? We have to use SPT method. Now again they are giving, there is one more question on the SPT. They are asking that average, find out the average flow time using the SPT, method. Okay, let us check that what we can do here. Okay, first of all, when you are going to use the SPT, let me draw the graph here only. This is job, this is PT, this is T in, and this is T out, T in and T out. So in what order we are going to perform the job? Job 1, 4, then 5, then 6, then 8, then 9 and 10. This is the order in which we are going to perform the job. We can give the name also, but no need, because we have to find out the average flow time. And please remember, what is the formula for average flow time, bachcho? The average flow time is the summation of all T out divided by N. You remember that I have covered this part is in relation with queuing theory, that T out is the WS, T in is the WQ, and PT is 1 by mu, the service time. So this plus this will become T out. So let us run the machine. And start it. 0 to 4, 4 to 9, 9 to 15, 15 to 8, 23, 23 and 9, 32, and 32 and 10, 42. So this is what? Okay, so don't take the 42. What I said, that we have to add the T naught. Okay, average flow time. So 4 plus 9 plus 15 plus 23, 15 plus, okay, plus 23 plus 42, not 42, 32 plus 42, okay, 42, and divide by what? Divide by 6. So we can find out the answer here. What is that? 4 plus 9 plus 15 plus 23 plus 32 plus 42. Okay, so this is 125 divided by 6, so this is 20.83. This is 20.83. And if the data is in days, definitely we can, yes, the data is in days, so definitely I can write the days here. So this is the value of the average flow time, average. Okay, so where is the answer? Yes, here is the answer. So this was the correct solution of this problem. Now now let us, I think this was the last question in the slide. Tomorrow you will be having the session with the Vishwajit sir, theory of machine. So don't miss it, don't miss it. This is, see, this session is very important for you, because some new things you can learn from this part. You can learn from this part. Okay, some confidence, more confidence you will be getting with when you are going to solve the problems with the teachers. Okay, done. So wish you all the best for your upcoming examination, bacho. I hope that you are doing well. Okay, I pray with God that that day will be your day, because you are putting so much of efforts. Okay, done. So God bless you, have good success, good year ahead, successful year ahead. Okay, thank you so much. Wish you all the best for GATE examination. Thank you.